Okay, we're live. Saturday Night at the Atheist. Good luck. So Andrew wanted to talk to Erika first and had some questions. So we should get through that and try to be orderly, people.
Andrew gives me too much credit for not being an idiot. So
No, you're not. You're not an idiot. I can see how potentially if you pick any random person in the world, there's always going to be someone else that's smarter than that person. But like I feel like you're probably much more intelligent than I am.
Oh no. You've only heard me talk about things I know about. There's your problem.
Well, because because those are the things I like, anyways. I guess should I get into my questions?
Yeah, go ahead.
All right. So I brought up this email that because everyone here probably knows that I like to chat to professors via email. And it was related to our discussion earlier, and I kind of wanted to read a certain part of it and hear your thoughts, Erika, if that's okay.
Yeah, shoot.
So the question I was asking him is basically what distinguishes phylogenetic methods from distance or phonetic methods. And here's the first part of what he had to say. So the first general difference is that phylogenetic methods, cladistics, are concerned with ancestry, which is determined by finding characteristics that are uniquely shared by different critters. These characteristics presumably evolved more recently than others, so the relationship is closer. Distance/phonetic methods are not concerned with ancestry, only with overall similarity, so they don't really tell you about relationships. So that's the first part, if you want to give your thoughts on that.
Yeah, no, I think that's fair. I wouldn't say, I would kind of hesitate to use the word presumption that closely related organisms diverged. What did he say? That closely related organisms diverged more recently than organisms that have less in common. Because I guess I just have a problem with that being an assumption or a presumption, just because, okay, at least as far as I am aware, that's just something that is empirically viable, at least in every way that we can test it.
Right. Like you were talking earlier, for instance, about how you gave the analogy of you can show that gravitational models work because we can observe. I guess like it's kind of funny to think about because you're often taught in schools, for instance, that it's a stepwise method of linearity, basically, rather than you kind of assume, quote unquote. I'm hesitant to say that as well, but like you assume the model is true. If the model is true, then this should be the case. If and only if that model is correct, and we see those observations take place, so therefore the model is accurate for the time being, right?
Yeah, absolutely. I mean, it's like the scientific method, right? I mean, step one, after you kind of make an observation about something and form a hypothesis as to why that may be. But the first step is to say, okay, well, it seems like we see this is something that's happening. This, in that case, being in the analogy, being that things fall at a seemingly constant rate. I forget what is it, 8 point something.
So if I can narrow it down, can you give the analogy in terms of phylogenetics?
For like the gravity analogy with regard to phylogenetics?
For like the stepwise method, I guess, in terms of science, if that's okay.
Yeah, okay. Well, you would observe one that DNA is the currency of heritability. That means that organisms that reproduce pass their DNA on to their offspring. Then you would observe that organisms that you have seen reproduce seem to have more in common genetically when comparing wholesale genomes with one another than ones that did not reproduce from one another. So you and your father would have more in common than you and some dude on the street. From then, you would say, okay, well, these are my observations, and it seems like the more the more distant two organisms are, like the more genetically distinct the two of them are, the more genetic differences, and thus that heredity can be traced to the more distant two organisms are. Oh, sorry, I'm echoing a little bit.
I got rid of it.
Yeah, so with regard to those observations, you would then say, okay, because we can see this with individuals, this is probably something that works on the scale of populations. So you could do an additional observation and work with populations, you could do an additional one and work with species, and eventually the conclusion that you would come to is that as far as we can observe, DNA is heritable, and things that share more in common wholesale across the genome are more closely related than ones that aren't. That would be the observation. The prediction would then be that you can construct some kind of tree of relations with a bunch of different organisms, right? And that would be
universal, basically.
Sure, and you can do it with morphology or you can do it with genes. But in the case of what we're working with now, you're doing it with genes. So you might say, something that Standing for Truth mentioned earlier, you might look at the CO1 gene, right? And you might say, well, this seems to be very ancient, at least to eukaryotes. So I'm going to make the prediction based off of the fact that DNA is, something that's very heritable. All eukaryotes have this, that this gene is something that emerged at the very base of the eukaryotic tree. That might be the prediction that you would make. Then you might run a molecular clock analysis and look at those statistics on a bunch of different phylogenetic trees, looking at maybe when this gene emerged, right? And then you would come with the result, right? And that result would be something that is most parsimonious with the stats, the statistical analysis that you've done. With that in mind, you can then make further predictions with that phylogenetic tree that you've gleaned from that observation and the subsequent predictions. And if things continue to pan out, that's always going to be more subsequent support for that initial observation that DNA is heritable. And so basically everything that's ever been done on phylogenetics has bolstered that single premise that DNA is heritable, right? And organisms that share more of their DNA are more closely related than ones that don't.
Right. It works for the time being, basically, the model, I mean.
Right, and you could theoretically come up with some kind of idea of like, okay, well, how would this even be violated? Right? Well, you might see, you might stumble across some weird flatworm or something that for whatever reason it can do some kind of horizontal gene transfer. And then at that point, you might be able to say, okay, well, at least to the point of our flatworms, right? You can go back that far and the tree is still going to hold, right? But at that point, maybe you need to reassess. If that happened, you wouldn't be able to then say DNA being heritable in eukaryotes is something that doesn't work. You would just say there are exceptions to the rule at this point in time, at this level of complexity in organisms, if that makes sense.
Right. So basically, if this pattern were to be violated, this mix and match of unique characters would have to be more common, basically, than what we see.
Hello.
Yeah, you would require that for it to be violated. For something to be violated, you have to have a precedent for that, right? For you to be able to say, "What's up, Midnight Sparkle?" Also, by the way, for you to be able to say something can be violated, it has to be shown to be violated within the context that you're talking about at least once.
Could I add something?
Yeah, I don't care.
No.
Well, I just wanted to say, even if there is, well, I should say when there is horizontal gene transfer in multicellular eukaryotes, it is still something that we actually can detect because a virus is technically horizontal gene transfer of a sort. It's just not coming from another multicellular eukaryote. It's coming from a piece of DNA or RNA that was independent of that multicellular eukaryote.
Right.
And it's still recognizable as such. So just saying.
Right. So then I had one other email, Erika, or one other, I guess, section of an email that I want to have you give your thoughts on, if that's okay. Specifically,
by all means, these guys are going to know more than me for sure. But I can offer kind of my take and give my thoughts on it. Yeah, shoot. Sorry, I ramble.
Count on us knowing more.
Oh, sorry. So this email is about one of those predictions you were talking about, I believe, in terms of transitional forms, which I know I ask a lot of questions about because cladistics, which I don't fully understand, and transitional states, which I don't fully understand. You mix them together and you get something that I don't really understand. But anyways, so I was
can help with that if you
asking
want.
him. Oh,
Not meaning to interrupt. Just saying, if you want me to sometime, I can help with those
oh,
two
sure.
things you
Yeah,
just mentioned.
yeah. So here's what this professor said, that when asking about transitional forms and direct ancestry, basically this is how he responded: that for hundreds of years, paleontologists and anatomists have noted similarities between various groups of animals. Shared traits were considered a means to group these animals into classifications. Darwin argued that these shared similarities were evidence of common descent among groups, such that there would be transitional fossils linking these groups together, showing evidence of the acquisition of these traits through time. The work was to find and document these transitions in the fossil record. An example of dinosaurs and birds, the discovery of Archaeopteryx in the 1850s, was an example of a transitional fossil sharing some traits with dinosaurs, bony tail and teeth, while others with birds, feathers. And then he goes on to explain like what you were saying about phylogenetics. And then the other thing I want to mention basically was he says the more fossils we find, the more traits we can include in our comparison, and the more likely things will change in terms of homoplasies he's talking about. Instead of just 5 animals and 5 traits as above, we could have 1,000 animals with 6,000 traits. This gets complex because the more we include, the more minuscule the differences between groups. In paleontology, the difference between a bird and a dinosaur becomes blurry as to which trait you use to define that separation. Most of this is semantics, but shows that one group likely gave rise to another, especially if we introduce time into our study. And so what are your thoughts on all of that?
Yeah, I mean, I think that's wholly valid. I mean, if we had a representation of every single animal that ever existed in the fossil record, coming up with separations for different groups and when one thing gave rise to another definitively would be effectively impossible. The only reason that we can do this is because we've got such truncations where one group begins and one group ends because of the bias of the fossil record. This is why, for instance, we know a lot more about organisms with hard parts than we do about things like cnidarians, which are soft-bodied animals that don't fossilize very easily. But as you know, we've chatted about this before once or twice, but it all has to do with these suites of characteristics that define one group over another. In the case of human evolution, you would look at something like Sahelanthropus chilensis or other Miocene apes, and you would say, okay, these guys lived before we see any humans, period. And they have these given traits, and that would be, things along the lines of large protruding canine teeth, a rectangular palate, small brain case size with regard to body size, a quadrupedalism that is perhaps sometimes arboreal, a divergent helix, very specific ratio of arms to legs, a broad rib cage, things like that, right? Things that make, still today, chimpanzees different from humans. So the prediction that you would then make about that is, as we look through the fossil record, we should start to see the emergence of the human-like traits and the kind of disappearance, so to speak, of these more basal traits that separate us from the chimps, if that is, or from the rather Miocene apes, if evolution really is true. The interesting thing is, because of the nature of the fossil record, right, you end up with guys like the Paranthropines, which are a split-off branch group from the Australopithecines, and they are living at the same time. They're doing a lot of the same stuff. They're these bipedal megadont apes that, if you had found them, perhaps before you found Australopithecus afarensis, you would say, holy cow, is this the missing link? Quote unquote. Did we have a period of time where human ancestors just had these massive molars, a huge sagittal crest, big orangutan-style flaring cheekbones, and things like that? Because you would look at it and you would say, this has a whole lot of the characteristics intermediate from humans to chimps. But the second that you find Australopithecus anamensis or afarensis or africanus, you would say, but this one has a lot more of them, and it lived quite a bit earlier. So what that tells us is, particularly because we have contemporaneity with the Paranthropines and some early members of Homo and late members of Australopithecus, what that tells us is that we've got a split-off group going on here, particularly since we don't represent a lot of the derived traits that Paranthropines have. So the point is that as we fill in the fossil record, the job actually gets a little bit harder, right? As to coming up with these characteristics, but the gradient becomes smoother, which in turn informs evolution to a greater degree. And because we know things about geochemistry and the paleo environments and things like that, it tells us a lot more about, okay, well, why did these organisms evolve why were these characteristics selected for? In the case of Paranthropines, it's because the Australopithecines were a lot better at exploiting fruits and things like that. And the Paranthropines were like, well, what are we going to do? And so the ones with these big heavy molars were selected for because they were capable of cracking open these big nuts and eating these big tubers and things like that. So evolution is this big gradient, and that's what transitional species represent. And the cool thing about genetics is that we can use it to corroborate the emergence of these traits when we see them pop up in the fossil record.
Right. So I guess just to clarify something real quick. So when this, like, for instance, I read how he was saying that this trend basically that you're talking about of this gradient, I should say, a blurriness basically between certain traits basically shows that one group likely gave rise to another. And I guess what's confusing me is I thought that wasn't necessarily the case because evolution is branching, I guess, is my confusion.
Well, you have to think of it less in line of this linear succession, and more in the case of representing these suites of characteristics, right? So, like, if we had a very spotty fossil record, which we do, but let's say it was spottier, and all we had was a single Australopithecine, and let's say it was suprabasal, so it's Australopithecus anamensis, which is this, it's barely out of the Miocene apes. It's walking on 2 feet. It's got these reduced canines, but at the same time, its toe is still kind of divergent, and it's pretty much looking like an ape, like a chimp that's walking around on 2 legs, right? Yeah. If we had one of these guys, and then we had Homo erectus, and then we had a Paranthropine, one of those guys I mentioned earlier, you could look at these 3 individuals, and you could say, while certainly Paranthropus is likely a sister group because it's later than this Australopithecus, but it's got all of these traits that we certainly don't see in Homo erectus, which has some slight overlap with it. You can look at these organisms and say, still, Paranthropus represents an organism with a suite of characteristics that is more derived in some ways than Australopithecus anamensis. And what that suggests is that Australopithecus anamensis potentially has this lineage that continues onward, right, and is under similar pressures. So it may too have possessed those derived characteristics, like a more inline big toe or a more efficient way of holding its head directly above the body and in firm and magnum position and angle. So those suites of characteristics tell us that evolution is indeed occurring, right? It doesn't necessarily mean that you have anamensis, Australopithecus anamensis, begetting this Paranthropine, let's say Paranthropus boisei, which then begets Homo erectus. It's looking at how these traits are changing, because if organisms live in the same area, they're likely subject to many of the same pressures. Does that make sense? Sorry.
Right.
Can I clarify it a little bit?
Sure, and then I'll just wrap up my pod.
Okay. Imagine you're looking at a straight lineage. Imagine we had a fossil record of a straight lineage from one life form to another. Let's say, for example, from some really, really primitive monkey, barely recognizable even as a monkey. It's that primitive, all the way up to a specific modern human, you, for example. And we've got we've got all of the ancestors, everybody, every single generation, all the way. I mean, fossils don't form this frequently, but just imagine this extreme case. Okay. It would be probably pretty easy to tell that was, a direct, more or less direct, but you wouldn't be able to tell how direct. I mean, you wouldn't be able to look at a single fossil, say, of like 7 generations back from you and be able to tell, is that your direct ancestor, or maybe is that your direct ancestor's sibling, or your direct ancestor's first cousin. And in the same sense, when what we actually do get is sort of like that every fossil we get is either in a sense either a transitional fossil or a fossil of something that went extinct. It's either between one stage and another, or it is the end of its lineage. But even if it is the end of its lineage, it's still related to other things. It might be a branch that's close enough by that you can say, okay, well, this is about what we would expect between these two things. And so in that sense, it can be treated as a transitional fossil to be able to say, okay, we see this trait. Maybe you're talking about, between dinosaurs and birds. There might be some creature that had its forelimbs, its fingers on its forelimbs partially fused, and it's partially formed into a wing, but that particular branch actually went extinct. But it's still a transitional form between having arms and having wings. And you can look at that one and say, okay, well, here's an example of this transition. It has all these other traits, and it has this transitional trait that we can recognize as transitional, as opposed to just being transitional and not being able to be recognized as such. And as far as the branching goes, if you look at like a branch of a tree, which we know those are branching because it's a common usage of the word branch. If you take a branch of that tree and you break off some piece that has a fork in it that starts out with a single stick and branches off into 2 sticks, and you break the 2 sticks off the end of it, what do you have left? You got a straight stick with no forking in between. If you think of it, in trees they don't grow this way, but if that was growing like well, they sort of do actually, but there's growth around the sides and stuff as well. But if you just took that as like slices of the branch going toward the tips of the branches, you would have a linear piece in that one stick. But the whole tree branch isn't linear. The tree itself isn't linear. So there's linearness within the branching, is what I'm saying. Am I making sense?
Yeah. So I guess are you both saying that that paleontologists are using these traits basically, or I guess we should be thinking of transitional traits as showing what would have, or I'm trying to think of how to word it, but like how it did happen through how it I guess like how it like the
I think
it's sort of like
it's
sort of like a flow of traffic on. Sorry.
Oh no. All I was going to say is that it's not who begets who within a lineage. It's all about the traits. If you're looking at the difference between something extinct and something extant, and you're trying to say how this extinct organism ended up somehow resulting in a population and in a population and in a population that slowly becomes this extant population that we have. These suites of characteristics are going to be the best way to kind of map that evolution, rather than trying to find the specific individual organisms in a stepwise pattern along the way. And I would argue even that it's more informative because, like I said earlier, this is something that you can kind of map with other organisms that are existing at the time.
Right.
You can look at what pressures are at play, and you can compare that to the paleo environment, which is something that we can find a lot about based off of like geochemistry and other geologic clues. And you can kind of piece together what went down. But what you can know, if all you have is the extant, the extinct, and a single form along the way, what you can tell is that evolution is occurring. Because you're looking at those differences between the extinct and the extant, and you're finding out where that middle organism, whether it's more to the beginning or more to the end, where its characters fall.
I want to interject real quickly, and this is mostly playing devil's advocate.
Go
What
for it.
so what warrants you to say, for instance, that the two populations you're studying are in fact distinct, right? Could I not hypothetically say that these two populations are in fact the same, but that a subsection or some fraction of the population is undergoing some weird form of, certain genes being hyperexpressed in that population and just appear to be different from just
Like
appear
Homo sapiens and Neanderthalensis?
right? Couldn't I just say
Yeah.
that these two appear to be, different populations, but they're in fact just the same
That's really
population?
all we can say.
Real quick.
Without the genetics, that's really all we can say is they appear to be the same group, or they appear to be in distinct groups.
Right.
With the genetics, we can do a little more than that. Well, actually, a lot more than that.
Okay, hey Dak, hold on for a second. Andrew, do you have you covered all your bases that you wanted to inquire with Erika about?
Yeah, I guess.
I just had a second part to that question though, which would be what, and I'm not knowledgeable enough to answer this question myself, right? What about the genetics would prevent you from saying that was the case, right? That there was in fact some subpopulation that was just undergoing, like hyper-specific gene expression of certain, like morphological characteristics like skull shape or, whatever set of traits you're happening to use to distinguish two populations.
As opposed to one population kind of...
As opposed to sub-branches of a population undergoing like some weird-ass form of some genes being hyper-expressed over others in a normal population.
Right.
Well, those genes that are being kind of incidentally expressed are going to experience some kind of selection if they're actually creating a change in phenotype, which, because there are phenotypic differences between Neanderthals and Homo sapiens, this is certainly going to be the case. Now,
Right.
Those differences will be, like I said, they're going to be under the impact of selection. Positive, negative, neutral, right? Those to varying degrees, of course, but they're going to be under selection. And that selection is going to kind of decide, quote unquote, to use kind of an anthropomorphic term, whether or not those expressed traits, be they by chance or phylogenetic inertia or something like that, stick around. And if those traits do in fact stick around and continue to make this subset of a population distinct, there is the potential, especially in social species, that this distinction will become the norm, or that you'll experience a split of that population, and this will kind of be what's the word I'm looking for? It'll take hold in that subpopulation as well, and then that would be evolution.
Those distinctions. By the way, if I can clarify that, those distinctions that she's talking about being morphological distinctions or behavioral distinctions, as opposed to in the genetics, it's already a distinction, but we need to be able to look at that level to see that distinction.
Okay, can I say something really quick?
Yeah, go ahead.
If we have to let the snowflake speak.
What?
If we have to let the snowflake speak.
Let him talk.
Okay, the question I had, wouldn't the better word to use would be select rather than decide?
Yeah, probably.
Yeah, because select is more agnostic, I guess I want to say, because decide obviously implies intelligence, whereas select could be more of an automatic
either one
process.
could be assumed to imply intelligence.
Y'all are so
pedantic.
So pedantic.
Danny, okay.
Honestly,
but yeah, common usage. Yeah, you're right.
Okay, can we shift gears now?
Erika,
because...
do you see these pedants around you? You're surrounded by cattle.
Danny, you're in good company.
Danny kind of roped me into talking about philosophy.
Okay, hold on. I want to say something real quick. There's a difference between being pedantic and being clear and concise. I'm done.
Okay, thank you.
Now,
just to be intentionally pedantic, not much difference.
Hey, Dak,
okay.
Danny, we've decided that Danny would make some inquiries of Erika along a different avenue. And what was that? Well, anyway, he wanted to clarify some things with Erika. This may be a short discussion. It may be a long discussion. So y'all go ahead and do that.
Yeah, Erika, I'm
Can
not
I-
confident I understood you. And in the good sense, there's just like certain people that I listen to and they can't make sense to me. But no, I think that this could very well just be me, you needing elaborating on what you meant. But so we were talking about the sort of perspective of let's say a biologist when they look at let's say something like a land animal and that ultimately evolved from a aquatic animal, that they would expect to see some kind of transitionary form that would share both traits, and that would support the hypothesis of some kind of evolutionary change or evolution.
Like TikTok?
So you posed an issue with someone that instead advocated for that whatever that supposed transitionary form to be a kind of an independent organism that didn't evolve from anything else, or at least not to the extent that you would have. And there's a kind of denial of a principle that you were speaking about, right? And so I guess that's the context. I was wondering if you could elaborate what you meant there.
Yeah, so essentially the example that I was trying to make earlier would be like it would be analogous to someone accepting gravity working to a certain height and then arbitrarily saying it stops working there, assuming that we're dealing with things on Earth. So maybe it works up until 8 feet and then it stops working there, and then you say, okay, well, so you accept gravity, yes, and they agree. And then you say, so why is it that the impact of gravity stops or changes at 8 feet? And then they can't give you a reason as to why.
Can I
That
point out
That's
an
a really good
observation?
analogy.
Yeah. So
to make it more discreet, I think.
Could I please point out an observation on
I
that?
want to let Danny and Erika kind of get their thing out first.
Okay,
if we're using that analogy,
it's a really good analogy, but
if we're
wanted to
using
help
that
with it.
analogy, the usage of arbitrary, that just means that they make some kind of choice without reason. Is that the kind of there's no principled?
Oh yeah.
Yeah. So essentially, and I think the part of the problem here is that I use words, and sometimes I think they probably mean something more specific in the realm of philosophy, which is of course your field. And so maybe it could totally be on my end, and that I'm being imprecise on it. But when I'm saying arbitrary, that is what you said. That's what I mean. It's without reason, without cause, and for essentially in the case of creationism, I would argue a reason, a means to an end, right?
The point is that I think what I said earlier is that if they appeal to a particular reason, let's say they appeal to some reason, if it's not like having to do like a theological reason for why the gravity just doesn't work beyond a particular distance, then you're just going to be like, okay, well, that just doesn't have anything to do with biology, right? I can grant you that, but that's just not in the purview of what we're talking about. Now, is it do they not even offer that? I'm not so sure.
It comes from a stance where they will say, and the individuals, I'm strictly talking about the folks that I engage with, they'll say something along the lines of, science supports young Earth creationism. And then the details of that will be like, okay, well, you've got to be able to come up with genetic separations for these kinds, limits for evolution, in order to kind of preclude this common ancestry, right? And like I was talking about earlier, because DNA is essentially the currency of heredity, you have to come up with a line that this can't cross. But the problem is it's ubiquitous across eukaryotes, right? Heredity is ubiquitous across eukaryotes, just like gravity is ubiquitous no matter how high you go within the realm of Earth, right? It's like that things will fall. They're going to be impacted on. Unless you can present a reason to suspect that this is something that can be violated, you have a problem with saying science supports it. It would be completely different if these people were saying, I believe that there's a theological stopgap where evolution just can't cut it. And then I would say, well, that's a faith claim or a religious claim, and God knows I can't answer that. I don't know very much about theology at all. But the problem for me, and for general conventional science comes when someone says science supports this. And if we're going to enter into the realm of the empirical, then you have to play on that field, right?
Yeah. So these constraints on heredity, I mean, are there? What do you mean by constraints? Like I gave an example of a tornado producing an organism identical to a fly that was that was a product of evolution, right? Would biology, or at least more specifically evolutionary biology, be in trouble as a result? I mean, it just doesn't seem like that it would be in trouble.
Well, in the realm of what supports evolutionary biology, you've got supports from so many different kinds of fields and subsets of biology. No, I don't think that would end the conversation. But I was thinking, I was thinking about our conversation earlier, and I was thinking about the word choice that I used, and I was like, okay, in your example, I would posit that empirically, that's in the realm of science, right? That's not possible, and that's the wording that I used. And I was thinking, okay, why did I use the word possible? And I was trying to come up with a couple of examples later on, and this is kind of what I came up with, right? So it's like, if I run at top speed, I'm going as fast as I can run at my best friend, and we're running right at each other. It is, I suppose, and Leo's going to crucify me on this if I get this wrong, right? But I suppose it's possible that we could collide in such a way that we quantum tunnel through each other. But probably not going to happen, right?
Extremely unlikely.
Well,
yeah.
Don't tell Leo he's muted. Don't tell Leo he's muted.
It's okay.
So easy on Leo.
There are two
Yes,
forms
but it is
of
possible. There is no impossibility with macro level, like a baseball tunneling through a wall. The amount of times that you would have to throw it at the wall to increase that probability to a place where it might actually happen is so astronomically large that there's no real world way you're going to reach it. Tunneling is possible with macro objects.
Every millisecond for the entire duration of the universe. Won't happen yet.
Never underestimate a man with determination. If you sort of fall many times, it'll happen.
Presumably there are physical constraints in the world, Erika, right? And so there's a sense in which we can say things can and cannot happen independent of logical constraints.
Right, and the argument that I'm trying to make,
and we can also demonstrate why,
is essentially like, you can have things that are technically possible, even though that that possibility is so, like Leo said, so astronomically low as to barely be on the playing field at all. But let's say instead I said it's possible that the sun could just appear in the same space as the Earth and consume it instantly, right? That's not possible in the same sense because there is no known mechanism by which that could occur. And I would argue that
would you say it's physically impossible then?
Yes, it actually is physically impossible.
But you see, I don't see a physical impossibility of life coming from non-life, right?
Well, no, neither do I. In fact, I think that's.
Say either.
I would say that life coming from non-life did happen, like straightforwardly. There's no debate about that.
But then what does that do?
It happened naturally.
It's just we don't know how. Non-life happens all the time, but that's a different story.
Well, the point there is that then, if that's possible, then any laws about DNA just kind of
no, that's not true.
Wait, what were you going to say? Any laws of DNA kind of just what?
Well, in terms of it, the heritability-ness of DNA is compromised, right? In terms of it being construed. And
wait, what?
No,
how?
Well, it seems like if it's possible that an organism with various genes could arise from non-life.
What?
Okay, the issue fundamentally is there's a level of selection based upon
which of those monkeys could write Shakespeare's works.
The thing is, that's a valid consideration, right? And in the origin of life communities, the thing that prevents that, right, the thing that mitigates that as a possibility, is the fact that certain genetic systems, which do develop alternative forms of being able to replicate genetic material, right? Some are going to do it more efficiently and at a higher rate of fidelity than others. And logically, those that are best and are able to do it the quickest are the ones that are going to predominate. Those populations.
I don't see how this is a response. I'm just saying it's physically possible for a fly to be assembled from a process in which didn't involve previous life. right?
So
Yeah,
I
but
think the,
hold
I
on
think
here,
the
because Donald
on.
explained that earlier, that would be a fly in terms of what it looks like and how it operates, but there wouldn't be any base genetics for it, so it's not really comparable to life.
Wait, why couldn't there be?
There's a way. I think something I think something that's being overstated here is that what possible means in terms of science, right? So when we describe something as being possible, right, be it that this chemical reaction is possible or this physical process is possible, what's meant by that is that there is a mechanism, there is some way in which that conversion can take place, right?
Yeah.
There is some process which...
So you're making the claim there's no such mechanism?
So I think
No.
How the fuck did you get that?
I think I
We
get
probably should.
What I'm saying is that
If I can
there
just
may...
interject, we probably should be making more use of the word plausible.
Right.
Yeah.
What I'm saying,
Yeah.
what I'm saying is that I'm not denying that such a mechanism can't exist. What I am saying is that there is no mechanism so far, right, that has demonstrated how that process could occur and has been physically demonstrated.
That just sounds like incredulity or something. We haven't seen, we haven't seen, or ignorance, right? We haven't seen such a mechanism. Therefore, there is no mechanism. Like, what are you trying to do but undermine the hypothetical?
So I think
what I'm saying is that based upon the claim that's being made, right, I haven't yet seen positive evidence for which I can take that claim seriously and endorse it.
How does that apply to the hypothetical?
The hypothetical in this case makes a claim about the mechanism for how this type of thing can form.
It's some unknown mechanism. You don't know it.
Okay, then how can you claim it does anything?
Yeah, but
so what are you claiming?
Hold on, really valid point.
Before Danny, speak, please.
Danny,
I'm listening.
What are you saying? What are you suggesting happened genetically that is possible with a really unbelievable accident? What trait?
Just take your average fruit fly. Now, suppose that average fruit fly was produced by some unknown mechanism that didn't involve a previous life form, right? So that means that I don't think that there's anything wrong with that in terms of its physical possibility. So I think that has implications on how we construe constraints in terms of inheritability.
No.
Are you talking about including its genetic sequence?
Yes.
No, he's talking about a fruit fly that's coming
even the genetic sequence was put together entirely by random.
Yeah, something it could be a tornado, but it doesn't matter what the mechanism. It's unknown physical mechanism that doesn't involve life.
Yeah, we have no reason. We have no reason.
Like Star Trek
we have
transporter
no reason to consider that.
Until
we have no reason to consider that.
Okay.
I don't know. So you're just not engaging with the hypothetical. It seems like
the hypothetical is so far-fetched and has so little to do.
Wait, hold on. I have a question.
Jesus,
what is the hypothetical? What is the hypothetical?
Some fruit fly was assembled from not by some mechanism that didn't involve any previous life form.
Do you understand methodological naturalism?
Well,
yes, and I'm not. That's not being
apparently
compromised. That's not compromised here. I'm not. I take methodological naturalism to not presuppose intentions, like fairies or God, right? So the point is that here I'm positing some unknown naturalistic mechanism that did not involve a previous life form and which produced a fruit fly, almost identical to whatever fruit fly might exist outside my window.
Well, why would you do that? Why would anybody do that?
Until such a point in time where that mechanism has been fleshed out.
No, you're just not engaging with the hypothetical.
There's an applicable example.
No, I can engage with the
applicable example.
But here's the thing: if the content of that hypothetical hasn't been laid out, right, I can't assess whether or not that hypothetical is actually plausible and being manifest.
What do you mean by plausible here?
As something that has been observed instead of just existing in the mind. You're just not
interested in the hypothetical. Who's interested in the hypothetical? Anyone here?
I'm interested in the hypothetical. I just want to see what it actually
You're
says.
trying to undermine it when there's nothing wrong
I'll
with
address
it.
that hypothetical.
No, I'm saying if the hypothetical does in fact have any credence, right?
What does that even mean?
I'm trying to explain. If I could stop being interrupted.
It's extremely unlikely.
I'm saying that that if the hypothesis is
Absurdly
credible,
unlikely.
there should be a way in which I can test to see if what it claims does align with the state of affairs.
What are you talking about right now? I don't know what someone else can explain to me.
Danny, can I address your hypothetical directly?
No.
Can you outline his hypothetical?
Yeah, here's the hypothetical, right? That some unknown naturalistic mechanism produced a fruit fly, and it didn't involve a previous life form. I don't think that's anything. That's definitely logically coherent, and I don't see any physical impossibility.
I'm willing to address that if you'll let me.
No.
Nobody said there was something that was physically impossible about it.
Then why are you trying to undermine the hypothetical?
I'm not undermining the hypothetical.
Well, then
empirical basis for it.
I'm saying since there is no reason, since there is no evidence in favor of it, I have no reason to accept it.
What is that? I don't look. That's just saying that you don't want to engage with the hypothetical. So I'll move on to some of the.
It's saying that there is no implicit empirical basis for what you're proposing.
I'm not describing the actual world.
I've offered to engage a hypothetical. Will you let me?
Well, describing the actual world means nothing.
Okay,
it's not the actual
world. You don't want
world.
the hypothetical engaged.
Let
you don't really want it engaged. If you're going to turn down
yes, I cannot hear
because I've offered to do so.
Would you please
let
allow
Dak
speak
go
to
for a
talk?
minute and don't overtalk me, Dak.
Sorry.
When I'm talking, I'm trying to moderate. Please don't overtalk me.
Yeah.
So it's your turn.
Trying not to.
Your turn.
All right. Thank you.
Yeah.
Thank you. Okay. Craig Ventnor has made something that is sort of close to an example of what you're talking about. So it demonstrates how possible it could be if you could consider it possible. And this does depend on how you define exactly what's possible. His team basically took the DNA of a bacteria, genetically sequenced it, put that information into a computer, made some changes to it, stripped down a bunch of stuff, took out everything they basically knew they could take out and have a reasonable chance that it would still live, added in some stuff that basically amount to a signature to say, we made this inside of that DNA or that genetic sequence, and then turned that genetic sequence back into DNA by putting it together one nucleotide pair at a time. So they literally built it. A tornado, of course, is not going to do that because a tornado isn't going to put those pieces together like that. But assuming that it could, if we were to go with that hypothetical and assume that a tornado could put together all of the little parts of the molecules and make everything like that, if they had done what he did, they wouldn't call it, the original bacteria. It's a new one. But if they had reassembled not only the genetics, not only the DNA of that bacteria, if they had built the outer shell of the bacteria and all of the individual molecules inside of the bacteria and assembled the whole thing together, then yeah, I don't see any reason why they wouldn't call that the same one. If they had done that with a fruit fly and built a fruit fly that way, yeah, we could call that the same fruit fly. But if you look at the process that way and how detailed the work is that they've done so far and how much work went into that just to even make just the DNA of a viable bacteria, which they did do, by the way. They made a brand new bacteria that way. But just to do that much, if you can imagine that, how many times over it would be to make that fruit fly, it is extremely unreasonable.
Fine. We got it. Okay. Okay,
Erica,
Danny.
But yes, it would be a fruit fly.
Danny, somewhere back here, I kind of stated, okay, so are you talking about something that is so unlikely that it could be ID or it could be God, could be any mechanism? So what is the purpose of entertaining such a hypothesis?
It's to show that
what good is it going to do us?
The point of the hypothetical is to show that there are no laws of DNA. There are no principles concerning DNA.
No
What do you mean?
principles or no laws.
Do you mean like in how it operates?
But there are principles and there are laws.
Yeah, they fundamentally break down to molecular mechanics, like
I'll
chemistry, immutable.
Okay, they're not called laws. They're called.
So
it's basically they're based on smaller laws. How things work.
Let me soften the claim.
Okay.
Let me soften the claim that there are no laws with respect to heritability of DNA.
There are.
Yeah,
Again, it hasn't shown that either.
Kind of
I would argue in the same way that you could have a tornado go through a junkyard and arrange atoms in such a way and the subatomic particles in such a way that you get a particular element. I would argue that even if that were the case, let's say it arranged into uranium-238, for instance. That uranium atom, supposing that this tornado arranged it in such a way that it is identical to the regular formation of a uranium-238 atom, it's still going to be unstable, and it's still going to decay into uranium-236, right? If I'm remembering that process correctly. So the physical laws of the world that we live in govern the chemicals that make DNA up, and govern the chemicals in the way that make organisms up, in such a way that if they engage in the process of reproduction, the inevitable response is that DNA is going to be the heritable element, regardless of how that fruit fly was formed. Regardless of how it was put together, if that fruit fly reproduces, you're still going to get heritability.
Well,
Exactly.
Okay, but that's a tautology, right? If it reproduces, there's heritability because reproduction is understood in terms of inheritability, right?
Exactly.
I agree with that because I think I would argue that heritability is I don't know. I don't think that there's like necessarily a law that kind of governs it, but in the way that most biological processes,
It's an emergent property.
Yes. Okay. Yes. I think that's a fair way of putting it. It's an emergent property of the chemicals that essentially engage with one another in the act of reproduction, from simple eukaryotic cells that are dividing in meiosis, for instance, or mitosis, for that matter.
Well, I think the general claim that I'm making is that this idea of there being principles of heritability or
But there are.
or DNA are not going to be they're going to be the sorts of ceteris paribus clauses or laws, and that's going to just imply exceptions.
What does that term mean?
They're physical laws in the same way physical law.
Like all things being equal, like something like Mendel's laws might be construed in terms of ceteris paribus laws.
How do you spell that?
But that isn't the way. That is not the way physicality or laws worked. Okay, you're saying that because some crazy accident could happen, that we're going to tear it all down and say that there are no principles that we know about DNA. And you're talking to people that know genetics here, and this is just like crazy talk. I mean, you're not making any sense at all if you're trying to push back upon the laws that we do know about.
Look, I understand you disagree with
whether
the
you call
claim,
them laws or
but
not. You're
you
saying
should-
that because there's an exception, that we have to throw aside everything else and say that, genetics
No, I'm
doesn't
not
work.
making
And then
these
what is the
claims.
point? What is the point?
The point is that for someone to reject that there's like some kind of causal tendency with respect to inheritability of DNA, it's not irrational. I don't see why anyone should be committed to that.
It's
Who's
highly
rejecting it?
irrational to
Nobody's
reject that.
not entertaining it.
So let me ask you a question, Danny. Do you think that there's a difference between rejecting something like heritability outright versus accepting it to a point, but not defining the nature of that point? Because that's what we see with folks who are into ID and intelligent design, right? It's not that they're not accepting heritability. It's that they accept it and they utilize it to bolster their point quite frequently. But at some point, for reasons that at least I'm not aware of, despite looking, it simply stops working. So do you think that
Yeah, they might be special pleading. Is that what you're just saying? Is that what you're saying?
Yes.
I don't know. I guess you would know. Yeah, you would know more than me. Maybe it is special pleading.
Yes, essentially,
likely
there's
is.
Yeah, I mean, I don't really. I mean, with respect to special pleading, it's going to be a little bit more complicated, I think, for biology. But I don't really. You have to give me a specific example, and I have to come to a particular understanding because I'm not. You're very well versed in the empirical stuff here, and I'm not. But the point is that if I can establish that there are no laws of heritability, inheritability with respect to genes, right? Then it seems like we're just talking about a kind of loose inductive inference about what we should.
Except the laws that describe how genes are inherited are the same ones, are emergent from the same ones that describe how an electron moves through a magnetic.
What do you mean by a law if it has exceptions?
Okay.
Can I draw an analogy here? Since I have
Go ahead.
talked in like 10
Scientific
minutes.
laws are not prescriptive.
Leo's turn.
So heritability, I'm going to draw an analogy to, it's like you saying, well, what if there was some unknown natural process that could build something that's exactly like an atom at a particular energy level that's higher than its ground state. And then we say, well, it's still going to have temperature in some sense, because temperature is an emergent property from the amount of energy that is contained within the atoms that make up a material. Just like heritability is an emergent property out of the way that these fundamental molecules interact. So if you have those molecules interacting in the same way, the emergent property is inherently going to be there, because it is the pattern that emerges out of those fundamental interactions. Just like if a tornado takes a bunch of protons, neutrons, and what have you, and smashes them and makes an atom that is a material made from atoms that is at an energy level higher than its ground state, it's going to have temperature.
Yeah, I might have some fundamental issues with like this notion of emergentism, but I think the idea is something like, well, I mean, I don't know how to respond. Maybe the point is that the sorts of facts that emerge from these like more fundamental facts seems to operate with more exceptions than the fundamental facts, right? And so I just don't think it's easy to characterize what's going on that level, with the level in which there's supervenience or emergent, where the properties that emerge in terms of laws or terms of principles. I think, and that's what I was kind of wanting to contend with Erika, although I don't think that I'm defending what the creationists are doing. I don't think that's what I'm doing here, because I think I fundamentally agree that what they're doing might be something like special pleading or ad hoc stuff. I don't know what they're doing. You experience that.
I don't think I didn't interpret you as defending them, because their stance would be the same as that of conventional science. It's just at some point the emergent law, let's say, colloquially law, the emergent processes, let's say, mechanisms, that result in heritability stop working at a point by which there is no reasonable basis to suggest that it would stop there, particularly because it's different depending on which group organisms you're looking at. So, for instance, the area where evolution just can't breach the differences is quite different when you're comparing cats and dogs versus humans and chimps for creationists, despite the fact that the latter comparison is indeed smaller on multiple orders of magnitude.
I think the general direction that I'm going here is that, okay, look, there's this kind of tendency with respect to genes and inheritability. By the way, is it heritability or inheritability?
Things are inherited, but it is heritability.
Okay, thank you. So there might be this principle that helps us understand genes and heritability, right? And you're saying you're kind of holding on to that as to show that the way you're going about doing biology, it's not quote unquote arbitrary. You're holding on to the principle, and then what the creationists are doing are only holding on to it when it's convenient and letting go when it's inconvenient. I mean, I can understand that, but what I'm trying to get at is, okay, why is it that we're holding on to this principle that concerns heritability in genes, right? I was trying to construe a hypothetical that everyone so viciously tried to undermine, and which is physically possible and wouldn't undermine anything we know about biology.
I think the problem there is that big things are made up of small things. That's something that we see just in our reality, right? The same thing for the atoms that make up an element as goes for the amino acids that make up, or nucleic acids rather, that make up a strand of DNA, right? So because that is the case, you could technically, anything that is made up of smaller parts, you could apply that tornado analogy to, but that doesn't tell us anything about the natural world in the sense of the processes and mechanisms that govern it. It can't make any predictions, and it's great for a thought experiment, I think. It really is. But from a standpoint of what is the point of science? What does science do? I think it doesn't really say anything, if that makes sense.
Well, earlier, okay, do you think there's a principle of genes or some law of genes?
Yeah, so I looked it up in the meantime while someone was talking, because I wanted to see, and there are indeed like laws of inheritance.
Well, there's like law of segregation, independent assortment,
Right,
but those
yeah,
are all going to be catered.
Mendel,
Those are going to be cateris paribus clauses, right? They're going to be look, given these conditions, right, and those are going to be specified. That you'll expect to see this outcome, right?
Yes, agreed.
Okay, so
but I think though, as a quick aside, I think that the way that you're kind of treating genetics and genetics within the subset of biology, you could do that to any area of study, period, in the realm of human understanding, right? You could essentially boil it down to the what you call them ceteris paribus principles, right? And you could say once you boil things down to smaller levels, right? And you could essentially use that to in the way that you're trying to do it to genetics now, you could essentially do that to anything. I think this principle could be universally applied, and the reason that I think that is in the sense of what is science for. The reason that I would say that that's kind of problematic is because it doesn't really result in anything other than saying everything is kind of arbitrary isn't the right word, but maybe that will convey what I'm trying to say.
Kind of what he's getting. Could we let Dak get in with an attempt?
Yeah. Yes, I'm going to another beer while this is going on. Hold on.
I want to say something about such laws. If when we're talking about, for example, the physical laws, the laws of physics. If you go back to tiniest fraction of a second after the Big Bang, the laws of physics aren't like they are here. We make these laws based on observations. They're not prescriptive, they're descriptive. They say, in this environment, in this circumstance, this will happen, and here's how it will happen, and here's the math behind how it will happen. It's all descriptive stuff. And when you're talking about a hypothetical where a tornado does the equivalent of 1,000 people working hard on a science project and all kinds of technological equipment and everything, if all of this stuff is being done by a tornado, then you've basically invalidated the conditions under which the law applies in the first place. You haven't invalidated the law.
Not if it's cateris paribus laws.
You haven't invalidated the law. You've invalidated the conditions under which the law is expected to be able to be applicable to do anything, because technically there is no difference in that respect between a tornado building a fruit fly and a team of humans building a fruit fly. It's just a question of how likely it is to happen. The team of humans is much more likely to pull it off than the tornado. The tornado is extremely unlikely to pull it off. But either way, they will have to do so within the laws of physics. And those recognized rules of how genetics work are all bound by the laws of physics as well. And
Leo,
yes,
please go.
There may be exceptions under certain circumstances, but they are consistent enough to be useful.
Leo, you wanted to say something, and then
Leo's turn.
So everything that Dak said is 100% on point, and just to kind of add to that, maybe to kind of like summarize in a sentence to put the greater point that he was explaining, the laws of physics are not rules for how a system operates. They're descriptions of the state of affairs of physical systems under a given set of conditions. If you change those conditions, you can change the way that the system operates. This is why in quantum mechanics, perturbation theory is a big thing, because when you perturb systems, you can completely change the way that they operate. Laws of physics are 100% descriptive, and most of them are probably drastically different less than 1 second after t equals 0, if such a time exists.
Immutable.
The only laws you could say which are prescriptive in a way are mathematical laws.
Yeah. Physics probably has them as well, but we don't have access to them. They're underneath the laws we're describing.
Yeah.
Right. There's nothing necessitating our scientific laws like the law of least action or the way we define potential energy to be what it is, right? It happens to be a description of how the world around us and how particles in this world behave.
Yeah. The world around us, which is a very specific subset of the world as a whole. Like
Erika,
I said,
the point
if you're inside of a neutron star, the rules change a little.
The point is that if these genetic laws are understood in terms of ceteris paribus laws, right, then anyone, right, that says, well, look, you can have this kind of effect, or you can have these antecedent conditions in which you wouldn't get that sort of effect within the caeteris paribus condition, they're not like anti-science, right? Or they're not going against the laws of any kind of natural law, right? And I think that's the thing with right. And I don't wish to characterize the people that you talk to, but like if let's say we're a theist, right? And I thought that there were cases in which, I don't know, that fruit flies came about without a previous parent generation. I don't think I'm like undermining biology when I'm doing that, because if biology's uniformity or regularity is understood in terms of caeteris paribus clauses, there's no problem.
But that also doesn't change the way biology behaves.
Yeah,
because if it does, then it's not all other things being equal, and it's not caeteris paribus anymore.
Yeah, I think the primary problem with that is kind of what Dak said, but from the stance that I'm kind of occupying, and when I try to wrap my brain around the philosophy stuff, it gets a little much for me, just because I don't have a background in it, and I wouldn't claim to understand the basics, let alone the level that you're operating at. But like I think of it in the sense of like what science have I quote unquote done. And I'm writing a thesis right now on monkey teeth is the short version. But I would never take what I'm studying and propose a mechanism that is out of left field in the sense that it's not been a precedent hasn't been set for it, right? Because the whole point of science is that we are a bunch of organisms or beings, whatever, that have found ourselves in a world that is governed by a series of very basic laws that dictate what interactions occur.
But then, can I interrupt, or do you want to finish?
No, please. Yeah.
But then I think that's problems in terms of broadening what science is, right? Like I anticipate
it's
how you're going
to what science is.
Okay, I anticipate your behavior, Erika. I anticipated. I posit all sorts of explanations for things that I know that they don't operate in a law-like way. But I'm not doing science when I'm making these inferences, right? Like think about.
You aren't in the sense of what is considered. You're not in the sense that you're trying to create mechanisms for the minutia of my behavior. Now, broadly, you could look at what I do, and you could say, for instance, if I was trying to do quote-unquote science on human behavior, I could make claims about the ways that human societies, for instance, organize themselves and the individuals within them, making broad claims about the kind of macroscopic of demographics. And I could maybe look at how other organisms do that. And I could say, well, this seems to be a trend in social animals. And that would be a proposal for some kind of mechanism.
That would qualify as science under your view?
It would qualify under science if the way that I would flesh it out a lot more, right? So I might say something like animals like being close together because it is a great predator deterrent.
And then when people analyze basketball games and players, right, in terms of what's likely to happen on the field or on the court, they're doing science as well?
Well, no, because they're not operating under the same kind of principles that quote unquote science operates under. I mean, there's a clear delineation between different kinds of predictions that we can make as people. And some of those are rooted in very basic principles. So if you're going to make a prediction on something that like what Leo's interested in, right? So like if you're going to make predictions based off of laws of physics under given conditions. And you might say something like, well, given how physics is known to operate, something that is here on Earth is going to behave slightly different than something that is in orbit, right? And that is a prediction that you can make, but it's rooted in mechanisms and in laws that are something that to our knowledge appear to be rather set in stone. When you talk about things like behavior, we're just not at the level where you can boil that down to a series of, stepwise interactions that you could kind of call that science, in my opinion. It's a really, I understand that's probably not a very satisfying answer. But unfortunately, that's kind of the reality of where we're at. We're kind of in media res with all this stuff.
There's a mathematics that describes that. It's often referred to as chaos theory, where you can start with the same initial conditions of a system and have it evolve through time into completely different ways, even though you started with the same exact initial conditions.
Not exact.
Well, it's not quite that. It's the fact that
it's almost exact.
Yeah, it's the fact that slight deviations within the initial conditions of a system cause the long-term behavior of a system to behave rather chaotically. But they are, in fact, they can be predicted over the long term. They just appear chaotic.
It's a question of the stability of the system. If you have a very stable system, you can make small changes, and it basically will just kind of self-correct. If you have a very unstable system, a tiny little change might cause huge effects. And chaos theory basically is mainly about that border between those, where you have a system where you might make a large change and have only that change as an effect, and maybe even that change get neutralized, and make some small change somewhere else, and that small change just balloons out into a huge chain reaction of effects that never goes away.
It's a very common thing within dynamical systems where just describing one state isn't sufficient to describe the overall behavior of a system.
Can I attempt to refocus this a little bit? Danny, what would you have us do in genetics? What is the input? What does this imply that we should do?
What's the right way to go about this?
Yeah, what's the right way to go about it?
I'm just saying that if someone were to deny lineage on the I don't think that that's necessarily a problem scientifically.
I just think that falls in line with, you could apply that to anything. Like, I guess my problem with your whole analogy is or with your whole kind of the case that you're making.
I think I get what he's saying.
Yeah, you could apply it to anything, right? Like you could do the same thing with
you think you could do it with gravity?
Yes, you could.
I really think that you could.
You could deny gravity here and come off as like, oh, I'm not against science?
Yes, you could.
Mm-hmm.
Well, then I don't know what's meant by gravity.
Well, I mean, you'd be wrong, but anybody can question any part of science. I mean, if you say that, that for example, if you hold something up above the ground and then let it go, like a rock, you say, well, it's not going to fall, gravity doesn't happen. You'd be wrong, but that doesn't mean that you're denying everything else about science. Maybe you're thinking there's an exception. Maybe you've even got an exception. Maybe you've
Do you think it violates principles of biology? Do you think it, my hypothetical, right? Do you think it violates principles of DNA or biology?
I don't.
I'm not convinced that it does.
The fact that you could take hundreds of billions of chemicals in form of macromolecules and build a fly, and you don't even have to use your example of the tornado in the junkyard, right? You could say, what if we could do this in a lab? I would maybe this is a bit far flung, but I would hazard that even doing that would still kind of fall in line with this concept of heritability, because it is by the principles of heritability that we came to know those blueprints for a fly in the first place.
Yeah, 100%.
I'm missing what you're saying. Heritability presumably involves at least the very minimum two organisms, right?
No, you can have something.
For example, we have.
It requires one at least.
Doesn't have to.
Yeah, you could have
So when some unknown naturalist, like a tornado or some weird thing that happened in the primordial soup, if it assembled a fly, for lack of a better word, I'm using the word assembled, but if a fly was produced, right, that would be heritability for you. That would be an instance of something being inherited.
If it was identical.
In the sense of your tornado in the junkyard, in my opinion, it would not. In the same way that it assembling a uranium-238 atom from a bunch of, or uranium-238 isotope from a bunch of different atoms wouldn't be the typical process by which that comes about. I think, though, that in the same way that occurring with the uranium, you would essentially be violating laws, be they emergent or non, under the same kind of concept, I guess. Like, I think those two things are analogous. And I think that in the same way that someone could say, I don't think the way that, I think that elements can come about in completely random ways, right? Like, I don't accept the stellar origin of a bunch of different elements, or I don't like the way, or the conventional science explanation, right?
What scientific problem has ever been solved by considering that fruit fly in a junkyard scenario?
Wait, is the question to me?
Yeah. Where has that particular methodology?
I'm saying that hypothetical doesn't falsify any theory.
I don't think it does either. I mean, but it's not describing heritability either.
Well, the point is that I thought that Erika was saying there was some kind of principle about DNA and inheritability.
Well, it's only a principle in the sense that it's a principle in the sense that it is an observation that's never been violated, and is the result of the emergent result, however, since that's the terminology we've been using, of laws that exist and are empirical in the barest sense of the word.
But the way that physical possibility works is that if given some law, right, then X is impossible, right? But the point is that the hypothetical I gave, X, right, doesn't violate any law, right? I could grant that there have been no observed cases in the actual world of this happening, but there's not going to be any kind of, law, right, that that's going to be like undermined if it were to happen, if it did happen in the actual world. And that's kind of the issue that I'm having.
What is the point of mentioning that, though?
If you look at
what do you mean by that?
I mean, that's very unlike some other. There are all sorts of observations that if we were to have, that we would have to like erase a lot of things on the chalkboard, right? I'm just saying.
Oh, sorry.
Okay. Would your result of the tornado? Would your result of the tornado be a member of the order Diptera? Would it be a member? Would your fly arranged by the tornado be a member of the clade, the order Diptera?
That just depends on the criteria.
Well, if it's not a fly. If it is, that's trivial. Then it's inherited. It's in the definition.
Well, if it's in the definition, there's nothing to contest.
I mean, that's like the chicken and the egg problem. I mean, you can have an egg that doesn't produce a chicken, but still produces something alive. A worm egg won't produce a chicken. If you've got an egg that produces a chicken, it was a chicken egg.
Look, I'm not saying that it's like not rational to think that, if you were like lineage and transitionary fossils, these are all very reasonable things to me, right? But I'm just saying that they're not built on laws or principles, right? Because if we were to see something, if we were to see something like a transitionary fossil or what supposedly is a transitionary organism to come about apart from like some kind of evolutionary mechanism, it wouldn't be a problem for evolution.
That would be an environment exception, not a law exception. It would be a case of another thing being produced the same way, like a human making a statue of a fly.
It would be.
It's not really producing the same thing, because a fly, a member of that particular order, is by definition descended from its ancestors. If you've got one that isn't descended from any ancestors, this is a new thing. It might be identical to a fly. We could call it a fly because labels are things we put on stuff so we can talk about them, but it would be an exception in other ways, and because of those other ways that it's an exception, it would not be an exception to the laws that you're talking about.
It would simply be in an instance where a phenomenon happens to emerge from a different set of physical parameters.
So I get the point. I think that the thought experiment works. I think that the kind of the problem kind of on your end, Danny, is the recognition that all phenomena that we see, be they mechanisms or trends or theories or whatever words we want to use to describe them, observations, consistent observations, that they are all rooted in other laws. And, it's kind of like, I don't know, like, I think I almost get the vibe from you that because heritability isn't described as a law, even though it's something that's never been violated to the point that it's it's a series of principles that work and have made predictions throughout time that have been greatly benefited the human species, really. But I think not appreciating the kind of breakdown of why and how processes in biology work and how they come about through basic interactions of kind of lower orders of small things impact big things, essentially, is what I'm trying to say. I think that kind of makes the analogy makes the thought experiment a little wobbly. Like not appreciate saying, okay, heritability isn't a law. Thereby, you're not violating the laws of science by saying a fruit fly that comes about through a tornado in a junkyard is a viable means by which you can get a group of organisms, a genera of organisms, if it's like a different or something. But I don't think that appreciates exactly what goes into understanding mechanisms and describing them, if that makes sense.
It doesn't. Also, there's a difference between having a hypothetical example and having an actual discovered example. If we actually found evidence that a fruit fly had been created by a tornado, if we could show that to be the case, that would give us some things to question about how that tornado did what it did. It tells us nothing about fruit flies. It tells us nothing about biology, because this is a strange thing that a tornado did. That would tell us something about tornadoes we didn't know yet. But we don't have any examples of that happening so far.
Yeah, I think
there are no exceptions known.
I think the point that you, Erika, in our last conversation, I think that you might have hit the nail on the head with the idea that it's just a kind of practical thing. But
what if we?
I don't know if that's what you meant.
What if we conceived of like another planet that has life on it, and we go and we study it, and it turns out life did not occur on that planet in the same way, or maybe even with the same chemical compounds, so on and so forth. But we did figure out how one form of life gave birth to its own generations, and finally there was some kind of evolution. Would the laws of heritability, if they were different, apply just for that one lineage of life? Would you still consider it like two laws governing two different environments? Would they still be laws?
The observed laws might turn out the same. They might turn out different. It would depend on their particular biochemistry and things like that. So it could go either way, but it still would not violate what has been observed with life as we know it here.
So to me,
because it's not that.
So to kind of build on that example, right? It could be that the type of life that we observe, right, in comparison to the vast life that exists potentially in the universe, is a rare exception, right?
It might be.
Yeah, the type of biochemistry that our system happens to utilize is completely foreign and completely, not non-existent in terms of other systems that perform that in biology,
but still self-consistent.
I think you're right, Danny. Like, I think it is a matter of practicality. I think that I would argue that to the best of our understanding, heritability is intrinsically linked to reproduction. Or maybe I'm mixing those up. Well, one is intrinsically linked to the other. But
I think that's a matter of definition, though, right? Is it not? The idea of linking in heritability and reproduction seem to be analytically connected.
Well, it's actually definitional. Even if scientists in a lab were to produce a fruit fly subatomic particle by subatomic particle, that would still be a fruit fly reproducing. It would then just be a fruit fly reproducing by different means than usual. And the end result would still have inherited traits.
I understand that you're using reproduce just mean to create or to produce or something.
Well, reproduction by definition is like to make a copy of something, right? So
make a copy of it.
Yeah, so if you're reproducing, you're making a copy of something, and it could be as simple as I'm female, right? So I make copies of, at least portions of my genome in the form of my eggs.
That's how it's used in biology. That's what reproduction means.
Well, reproduction in biology.
Then viruses reproduce.
In biology, well, the
Right,
thing is,
like,
I don't have to make a clone of me to reproduce.
They don't.
It can be an inexact reproduction.
What reproduction refers to, in the most simple sense in biology, is the process of DNA being replicated by a very, very complicated slew of enzymes that act on it and cause complementary.
I would argue that's making a copy, though. I mean, DNA reproduces,
right? But it's
copy DNA, right?
Right, but it's
there may be errors in that copy, but it's still a reproduction.
Yeah, sure, but exactly. I would argue that it's you could almost make the case that it's an attempt, right? It's an attempt to make the copy of something, and that environmental factors, as they tend to, act upon this process and screw things up. And that's actually how that's how you end up with things like sexual reproduction ultimately.
Well, and it's also the fact that these molecular machines, if you will, that act on these that acts on this biomolecule are not perfect in any sense. They make mistakes in terms of how they replicate, and sometimes mistakes happen. There are certain errors that these molecular machines can notice, but some that they aren't able to fix.
If I may draw an analogy,
and sometimes those
it's like having a copy machine that takes a copy of a map and makes a copy of it, but when the copy machine does that, there's maybe a millimeter thick line where it's just white all the way through. The fact that there's a mistake in that copy of the original map doesn't still mean that's not a reproduction of the map. It is for all intents and purposes.
Yeah. Well, the same as I was talking about recently about the French language. If you take the French word parler, any particular version of, because that's a spoken word, there are various written words in French that sound exactly the same, isolated without another word after them. So if I take P-A-R-L-E-R and I pronounce that parler, and somebody else hears that and writes down P-A-R-L-E-S, that's a reproduction. But it's a reproduction with a loss in the fact that in going from the written French to the spoken French, there became an ambiguity, and when they translated it back into the written French, they didn't have enough context to get everything right, but they still reproduced what they could. It's still a reproduction. Did I just lose everybody with that? Because
Erika, I'm going to think about it a little bit more. There's an incomplete puzzle piece that I have, and it's not on your side. There is something missing here.
It could be on my side. Listen, you give me credit. It could be on my side. It always could. Listen though. I'll think about it too. And also, I see Lena Powell is in the chat. I simply must take this opportunity to talk about racemization dating for just 5 seconds. Is that cool with everyone?
Thank you.
Absolutely.
Back to
who did you see in the chat?
Lena Powell was telling me earlier that racemization dating is a valid kind of dating, and I would like to discuss why it's not.
It is not.
And Lena, we invite you to come in.
See how that's spelled.
I know you're shy to do that, Lena, but please, we would just really get a kick if you came in and engaged in a discussion. But I understand.
I'm interested in her thoughts on it, because I'm going to give my take in my understanding of it. And if you disagree,
there's too many variables. There's too many variables affecting the rate, and it's only good for so long. I mean, it doesn't make any sense at all to use it, and I think they figured that out in about 2008.
So the thing is, right, and here's something that's kind of useful when discussing about chemical processes like decay or synthetic processes, is that all processes that pertain to chemical formation depend on other variables such as the temperature, such as the pressure, such as
acidity
of relative species, the acidity or basicity, like you mentioned. A change in any one of those will cause your rate to change over time.
Well, depending on what you're looking at, right? I mean, this is especially true for things that are organic, which is the challenge presented to folks who want to talk trash about carbon dating, radiocarbon dating. Okay, well, what we have a pretty good handle on what impacts carbon dating. and what impacts dating in general, and the law of radioactive decay, which is of course what radiometric dating, including radiocarbon dating, actually measures. What can actually influence rates changes dramatically when you move from organic to inorganic. And this whole thing with amino acid dating. Okay, so for folks who don't know, because there may be people out of the loop, so I'm gonna the brief overview is that there's this dating technique called amino acid dating. Racemization dating is sometimes what it's called, and essentially it relies on this. Yeah, it relies on this idea that biological tissues have amino acids, right? And amino acids can be decently robust. And, organisms tend to keep all of our nice little amino acids in the L configuration. It can be D or L. But when things die, they can't really keep them in that L configuration. And so they can slowly kind of transition into being, all L to...
they're not replacing broken ones.
Right, exactly. So the problem with amino acid dating, racemization dating. I've had too many seltzers tonight. But the problem with it is exactly what Speed mentioned earlier. There are a number of known factors that influence how fast this decay occurs. And when we're trying to date things, we have to consider what is it that actually makes a good natural clock. And good natural clocks have to have known initial conditions. They have to have relatively constant rates. They have to be irreversible. And they have to have a known final condition. Yeah. So if you have common environmental factors that can change the rate of something's decay, it's not a good natural clock, period. And the problem... Granted, oh, sorry, go ahead.
I was just going to say, granted, a poor natural clock is still potentially better than none at all. So if you had nothing else, it might be useful. And it may be useful in terms of maybe helping to verify some other reading, with all the variables, it shouldn't be relied on in and of itself, I would think.
It's not something you want to use when you're trying to measure timescales that are millions, if not hundreds of millions of years old.
Well, the problem, it's got a small half-life anyways, right? Like, amino acid dating, it goes 200,000 years?
Something like that, yeah.
Yeah, if you're trying to find out, if you're investigating a crime scene and you want to find out, when did this body die, it might be a little more predictable. If you're in a climate-controlled environment, you know what temperature it is. You don't have any flies around to have laid any eggs to use that as a guide or anything. Yeah, it might be better than nothing, hypothetically.
Yeah, the problem arises with the fact that we've got dozens upon dozens of methods that have constant rates, if you will, in the sense that, to what we know, they are not violatable in nature. Things like radiometric decay, which is of course my favorite, which has several different subsets. You can look at isochron datings of various types using different elements to cross-check one another. But this is something that is especially problematic if you're trying to argue for the Earth being quite young. Because you can take radiometric dating and, like we were mentioning earlier, you can corroborate it with non-radiometric methods, things like coral clocks or dendrochronology, ice cores, the nature of how sediment deposits, things like that. And so racemization dating is basically just a bad version of radiometric dating that changes at the drop of the hat. It's influenced by everything.
Wouldn't even make very good corroboration, huh?
You shouldn't use it for those reasons. But the biggest reason is that racemization dating has a terrible track record when it comes to making predictions about where things like oil is. One of my favorite things to harp about when it comes to knowing the age of the Earth is indeed very ancient, is the fact that a $257 billion industry annually relies on radiometric dating working. And the ironic part is a lot of these dudes are from Texas and don't believe in evolution anyways, but of course they use the methods that work to make them money. I mean,
they believe in that money.
I think they understand evolution and believe in it. I mean, talking to the people at the top, the super rich ones in control of the power, I think the thing is they don't want the other people that work around them to understand it because they don't want competition in their work.
Yeah, I mean, potentially, there's the famous, oh God, I forget what the name of it was. There was a there was some kind of, someone in the chat needs to tell me. I'll reach out on Twitter too, so I can tell you guys later. But there was like a young Earth creationism oil drilling company, right, where they were like, we're not going to use old world methods to find our oil.
Cyan oil or something.
Yeah, something like that, but they're bankrupt now, obviously. They did not find much oil because, as it turns out, seismic scanning for oil is super, super expensive when you can just basin model an area and find out if you've got, like, nice oil deposits. You know, looking for things like conodont teeth, right, weirdly enough, is something that'll tell you if you've got, you know, an oil-rich environment. These ancient paleo environments, which really clue in whether or not oil was conducive to forming, or any fossil fuel, really. Racemization dating also has this incredibly wide range, whereas you can get ridiculous precision with general radiometric dating. So it's bad for a lot of different reasons, but even then, racemization dating does not support a young Earth. You still have a maximum age of 200,000 years, and you're not getting below 6,000 every time you utilize radiometric dating. So for all of those reasons, racemization dating is it is not your ideal here. It doesn't make excellent, accurate predictions. It's influenced by everything under the sun. And anyways, racemization.
I did want to say really, really quickly. I stepped away when Erika said, "Here, let me talk about racemization." I don't even know how the fuck to pronounce it.
I believe it's racemization with a Z-A-T-I-O-N. I think.
Racemization.
Yeah, racemization.
Anyway, as I was saying, I leave and she's saying, "Let me talk about racemization." I come back and she said, "So that's what I have to say about racemization."
Perfect timing, Leo. Listen, I'm off my soapbox. That's all I had to say about that. And I'm good. We can talk about whatever now. I'm gonna just chill. I'm just big vibing over here.
I thought a little bit more about it. Well, I actually looked into a text, and they have you ever heard of the notion of resilience? I think this is an interesting term that I had not come across.
In what context?
The idea, in the philosophy of science context, right? The idea is that, like, there are some regularities that are resilient but have exceptions. So, but it's just like I don't know if that helps here, but
the concept you're talking about might be in alignment with what I was talking about earlier. Is as pockets of stability within a complex system, where and that when they talk about, for example, when they're trying to predict the weather. There are weather patterns that are very predictable and weather patterns that are very unpredictable, and in that sense, I think what you're talking about, you could consider those more predictable patterns to be more resilient. That if you, for example, the butterfly effect, a butterfly is not going to cause a hurricane somewhere under those more stable conditions. It's more resilient to the effects of the butterfly.
But the point then is that if someone could grant such a thing and then, like, operate outside of, like, the resilience pattern, and I don't think they would be, like, rejecting science. I mean, I think what the creationists are doing.
They're just stepping into the realm of unpredictability. That's all.
Well, I'm not describing them so much as maybe describing something else.
Conceptual vagueness. Is that what you're going on about?
What the creationists are doing?
No, resilience and
no, I don't. It's more like Mendel's laws. Like, there's resilience there, right? And like Mendel's first law, there's, like, the exception of Down syndrome, but there's resilience with respect to the regularity.
I see what you're saying.
That
would be like your fruit fly analogy. If a fruit fly was made by a tornado, like I said, that doesn't change the rules. It doesn't violate the rules. That is just something that would have happened because we have. Well,
there's not resilience. I think resilience precludes laws or rules, right? They're not supposed to be, like, you could say, well, look, there's.
I don't think you're using the term laws in the same way as it's used in science when you're doing that, because you seem to be thinking that if there's a single exception, the law doesn't exist. If there's a single exception, we have to look at why there's an exception, under what conditions there's an exception, and does that exception actually apply to the conditions under which the law itself was meant to apply. And if it turns out we have a certain exception that only happens under a certain circumstance, then maybe the law has to be slightly modified. Sort of like when Newton's theory of gravity was found to have certain exceptions, like the orbit of Mercury didn't quite fit, and then Einstein came along with a theory that covered everything Newton's does and then some. So it took care of that exception. So maybe we'd have to add an exception that says except in the case of miraculous tornadoes.
I just don't see why, if there's not necessity built in the notion of law.
Danny, you just went away.
I can hear.
You got really faint.
Yeah.
Oh, is that better?
Yeah.
Yes.
Okay. Yeah, I think that the point is that if it's an exception, if there are laws with exception, I mean, I take laws to establish necessity, and if it doesn't establish necessity, then they're just merely practical or something.
But it's necessity.
Right.
It's necessity where they're applicable. I mean, take for example, if you want to talk about a different kind of laws, traffic laws. Okay, if somebody's not driving on the roads, if they're out in the middle of the desert, traffic laws very well might not apply to them at all, because that's not what those laws were about. Now, I know those are prescriptive laws rather than descriptive laws, but in the case of descriptive laws, they also have a context in which they were made. That if you take away that context, if you throw in a magical tornado, that those laws don't necessarily apply there, because that wasn't the environment in which they were, in which the effects of them were observed and described.
The thing is, too, is that scientific laws are, so like when you say like the law of gravity or something like that, you're not describing like the mathematical form that like Newtonian gravity is embedded in.
Yeah, it's just the observation.
Right. What you're doing actually is you're describing the general behavior and the types of phenomenon that by which gravity actually describes. Right, and it's something which is the most general behavior that occurs.
Yeah, I don't. That doesn't.
It permits that there can be exceptions.
There's
to
no.
that.
Is there any necessity with respect to science?
None at all.
It doesn't deal with necessity.
Well, that seems to be an unpopular view.
It would depend on what you define as necessity, because I would bet most scientists would not define it the way that you probably would.
Well,
I think you're using that law in a way that doesn't get used inside of science, and by in any accepted amount. I mean, maybe there might be a scientist out there somewhere using it exactly like you're using it, but other scientists wouldn't understand what they're talking about. They'd get confused.
Most scientists aren't so up their own to think that the laws that we have are somehow prescriptive in some way.
I don't know how you're using the word prescriptive.
So I think really
It must be the way they are, that they are necessitated by something.
That's not what I don't. Go ahead, Eric.
No, I'm so sorry. I totally was interrupting you guys. Please continue. I don't want to interrupt.
Well, I was just going to comment on prescriptiveness. If the laws of nature are prescriptive, then they prescribe function, the function that they describe. Meaning that essentially the laws would transcend reality and tell it what to do. But that's not what they do. Reality just does what it does, and we can develop ways of describing these actions that oftentimes tend to hold quite consistently in stable conditions.
So you don't hold to non-causal explanation?
What do you mean?
We do.
Well, it seems like natural laws explain uniformity without invoking a cause-effect.
Well, see, I don't think that the laws of nature explain uniformity. I think that uniformity is something that arises out of the consistency of nature, rather than the consistency of nature somehow defining uniformity. Uniformity is itself a description.
Yeah, we use observation to make those laws. Yeah, you're right. That sums it up right there. They aren't meant to invoke a cause. If there's a cause, that's another step. That's where you come up with a hypothesis and you say, we hypothesize this cause, and then you test that hypothesis, and if you can't find any exceptions to your hypothesis being, showing it that it seems to be right, that can eventually be elevated to the point of a scientific theory that describes something in a very specific context and says these are the rules that we can apply to it mathematically, predictably, and it's not that's not just a law. Then that's above the law. That's actually making use of that law to do something beneficial, something productive.
Erika, what were you going to say?
Yeah, the only thing I was going
please.
to say is that I think it's really, really important that we actually appreciate the fact that a law isn't better than a theory. And like, what is a law and what is a theory versus, when we're talking about them in science versus colloquially, right? Because like a law is just used to describe some kind of action under given circumstances. But a theory is like this collective, group of observations that help us, describe how and why something happens. That's why germ theory is a theory and not a law.
Not really. I thought the distinction is that one posits a mechanism, the other one doesn't.
So a theory,
that's part of it.
So a theory
Well,
is a set of data
a hypothesis would posit a mechanism.
Yeah,
Right.
hypothesis or theory posits a mechanism, whereas laws explain without a mechanism.
Right,
Exactly.
that's how it
So what a
encompasses.
law-
Theory is
so what a
how and
law-
why something happens. That necessitates some kind of mechanism. How it happens, why it happens. In germ theory or in.
But those
And
questions
it
also
generally
apply to
defines the
laws.
Conditions
Yeah,
under which it
well, the
happens.
mechanism is there. The law just doesn't address that. The law is only addressing the observation.
Yes,
it's
that's
single
correct.
action, right? A law is in reference to a single type of action, right?
No, a law is in reference to an observation. A law is in reference to something that's observed. So the
So that
law.
would be an action that has occurred.
Yeah, well, she's right in saying a particular action in the sense that
Wait, and theories are not about observation? Wait, I'm
something
confused.
something
Theories-
happens that is an action.
Theories.
Sorry. I've had a couple of seltzers tonight. You guys are gonna have to forgive me for tripping over stuff. Yeah, when I say it's an action, I mean it's an action in the sense it's something that we're seeing under given circumstances.
Right.
Yeah.
A theory is more concerned with predictive generation. So a theory is a set of things that we've observed and that are consistent with a law, but it also predicts something about, but it also makes a prediction about the natural world. So it makes predictions about things that we should expect to see if this law is consistent.
Yeah,
So-
such as when the law should apply and how the law should apply.
Right. So
So
Theory-
natural laws, if they exist, they don't predict?
No,
natural laws are simply descriptions of things that we.
So they don't predict.
they
Right.
don't predict.
Theories, on the
Not
other
in
hand,
themselves.
Yeah.
theories on the other hand,
Observation that they usually hold true, that can predict to an extent. But yeah, the laws themselves, no, they don't predict. They're actually retroactive. They're looking at the past and saying this is what we've seen.
That might make sense. I think that. Yeah, I think the idea is that mechanisms do make predictions.
Right.
Laws seem to.
theories essentially serve as mechanisms and act as kind of borders for when a law should be applied, or when we should expect some law to be true or consistent.
So does that answer your fruit fly dilemma? Have we gotten to the core of it?
Well, the point is that if you're going to consider laws as if your notion of law doesn't involve necessity, then
It
there
doesn't.
are just laws everywhere. I mean, it's just nonstop. There's an infinite number of laws.
Waiting to be discovered.
that's right.
Exactly.
Can I make not really an analogy?
100%. Good job, Danny. Really,
I think that's very problematic for science.
it's not, because that's how
isn't.
science uses it. That's how scientists who are doing their jobs right.
Remind me
There's a
expect to be.
law of me over talking people, except when I don't over talk people. That's science.
There you go.
That seems ridiculous.
That's
Wait,
not
what-
all.
We can observe. I overtalk people probably more than I should.
Is this thing
That fact.
working?
Da-
know,
Danny, you're more sensitive to Dak over talking you than anyone else.
Yeah, that's all we're talking about when we say law. It's a shortened way of saying this is something we've consistently observed.
There's something. There is a missing puzzle piece there. There's something wrong with this.
I think the missing puzzle piece is it's not just a one-time observation. It's something that has been observed consistently
3 times, 4
enough
times?
to be able to
consistently
enough to say that it seems reasonably probable that we can expect it to happen again under the same circumstances.
Yeah, I don't think we should reduce science to like prior probabilities.
That's not reducing science. That's a step in science. That is an early step. Before we manage to go farther, we have to have somewhere to start with.
Consistency
it's sort of like
and
starting with science
reproducibility
fiction
are
and saying,
very,
hey,
very
we can go
important
from here.
So to answer your question, theories must account for all observations under a set of descriptions of the law, right? It can't just be one. It can't just be two. All observations must be consistent with it.
So can I try something here that might help really sum up the distinction between a law and a theory? Let's take the law of gravity versus the theory of gravity, which is not really called, that's general relativity. The law of gravity states that when you have two massive objects, whether it be the sun and the earth and the moon, I mean, we could build balls that can do this. The closer you get them, the greater the force that's acting on them is going to be.
Pulling them
There's nothing in there. There's nothing in there that tells you why they attract. There's nothing that gives a mechanistic operation for it. The only thing you're noticing is when two massive objects, the force felt between them is proportionate to their distance. I think it's more appropriately the square of the distance. But anyway, the theory of gravity says the same exact thing, but then tells us this occurs because those massive bodies curve the geometry of the space-time that they're in. So similar to if you put two bowling balls on a trampoline, they're both going to roll to the middle and rest at the center. Because the same basic principle with gravity. So where the law states this happens, the theory says, yes, this happens, and this is why. These are the conditions under which it happens. And as long as those conditions are stable, this will always happen in those conditions.
It seems like you're attributing necessity to it then.
Nope. Science is tentative.
But you just said, I don't know what you mean by must, but necessary.
Then I honestly I can't help you.
You don't
try to think of the word being used in a more nuanced manner.
Okay, Leo, whatever.
Well, at any rate, I hope at least we've given you some stuff to think about, and I hope because I think we got to the root of the problem there is as far as it's a definitional thing that science is using the word law in one way, you were using it in another way.
Yeah, but I think there's a reductio ad absurdum on your view.
If you look at the way scientists are using the word and consider what we've said about that, maybe you'll come to a better understanding of how
I'm saying there's a reductio ad absurdum on that view.
Well, I don't think there is. In what way?
For every inductive inference, it's going to be a scientific inference or something. Scientific truth.
No, not necessarily.
Well, look, it's just, for every inductive inference you make, it's going to be a law, right? Because there could just because.
Why?
Well, then wait. What? Are you saying laws can have exceptions?
No, because even though that's how science uses laws, not all laws that take.
Are you rejecting the necessity of a law?
Can I please finish the fucking
scientific laws aren't necessity.
Because look, then I'm not talking to you, Immutable, because you agree with me.
They're tools. They're not necessary. They're useful.
To you,
You're agreeing with me.
Okay, I'm also trying to explain to you that scientific laws have other criteria that they must cohere to. Not all of which inductive phenomenon or inductive criteria follow.
Yeah, I'm saying one of those is necessity.
Right, and that's not what science describes.
Nope.
Science doesn't describe what?
Necessity.
Science doesn't deal with...
I'm not saying... Look, do you really think I'm saying
scientific laws don't imply necessity.
Do you really think I'm saying that the laws themselves are necessary? That's not what I'm saying. I'm saying that what follows from them, there's a kind of necessity to that.
No.
There's
it's only consistent observation, not necessity.
It's just saying that X will happen except when it doesn't. That's what a law boils down to.
I'll give you a very easy to understand example. If you make up a law, the law of swans being white, if you had observed lots of swans and you consistently observed that they're always white, you could make a law of white swans and say, swans are always white. Doesn't mean that it's right. Doesn't mean there won't be an exception. Doesn't mean that it can't be overturned sometime. But that's how that works in science.
You think if we came across a black swan population, the law holds? That's your view.
Not really.
I mean, that law would absolutely not hold.
What did you say, Danny?
There is necessity then with respect to laws.
No, what you would be doing is you would be finding out that the white swan population, that the law of swans always being right, was overly stated. Instead, it should have been worded as the law that swans are generally white. It was a poorly worded law.
That's just a contradiction under my terms. Like to say that a law is a general truth.
It's not. It's an observation. It's a consistent observation.
Yeah,
that's all it is. And we can have other observations that might even be more consistent, that might contradict it entirely, but that we just haven't made yet. Maybe somehow we avoided the most common observations for a long time, and suddenly that might be completely overturned. But that's why scientific laws. That's why scientific laws have a very different status from scientific hypotheses and scientific theories, because the scientific law is only a consistent observation. It's just, this is what we've recorded.
Look, I consistently observe you speaking gibberish, but that doesn't mean there's some law of Dak speaking gibberish.
Okay.
If you think I'm speaking gibberish, you could make it a law. Yeah,
it's a law now?
Of Doc speaking gibberish.
So you know what happens to the notion of a law then? This is what a law becomes. It happens consistently, except when it doesn't happen consistently.
Exactly. You got it right.
It seems to me
it's not silly because the one thing that you're missing is that it states it happens under certain conditions, and then you're claiming, well, if we change the conditions, this doesn't happen, therefore it's not a law. Aha, see, I got you.
I didn't say anything about conditions.
That's because like I said when I first started talking, was that's the thing you're missing. Like F equals ma is a law of motion, except when it doesn't apply, like at the quantum level of reality, where it doesn't apply at all, and you have to use Schrodinger's equation.
Isn't that why people?
But you don't see scientists saying, "Oh, well, it's not a law." It is.
Isn't that why
we use it to send things to the moon?
Isn't that why
Newtonian physics wasn't replaced? Newtonian physics has not been replaced. We use it to send things into space.
It's just practical. That's what Erika and I agreed. It's just practical. But the point is that
of course it's practical. Why do you think we use it?
Because
falsehoods can be practical.
Observed.
Yes, you're right. Falsehoods can be practical.
Look, is Newtonian physics an accurate description of, as you I hate saying this word, reality?
No.
Yes, it's a very, very accurate description of reality.
To a point.
At a certain scale.
Who said no?
I don't know why.
So it's an accurate description, except when it's not accurate. Is that what I'm hearing?
Right. Exactly.
I don't think Danny understands that that's literally how all of science works. The things that we observe in biology are accurate and consistent until when they're not, like when we apply them to how stars work, because it doesn't describe how stars work. We have different ways of explaining different things because they operate in different ways under different conditions. They can't go between each and every one. So, of course, any one thing is only going to apply in that one condition, except when it doesn't, because you've changed the conditions. For Christ's sake.
Leo, you're very smart, except when you're
accurate, not. Danny. It is accurate.
Don't be an instigator. Please
it is accurate to
the point is that that's trivial. Look, I'm really smart, except when I'm not. That's a law.
I'm trying to give you a very very precise answer. It is accurate to a certain precision within a certain context.
Hey, Danny. Danny, real quick. Quick question. I need to debunk something real quick. John Maddox is in the side chat and says that you get treated way better on his channel. Is this true? And as an elaboration, which channel is more fun and which channel has the most?
So let me be honest. I'm much more aggressive here than I am in another channel. But so in that sense, yes, I get treated a lot better there because I'm not near as aggressive.
Well, I'm glad you're being more aggressive here because we get somewhere that way.
Danny shows his teeth more here, and so he's been in a lot more.
Keep it up.
Well, he needs to be
I mean,
wrong more here, so he has to be
we
more
will-
aggressive. So
we will
I was
all be
just- I
wrong
was
some of
thinking
the
exactly
time.
what Speed
We
said.
will all be wrong some of the time. We all have stuff to learn. And if you're relatively sure about something and you push that and we push back, well, maybe we've got something to teach you, or maybe one of us has something to learn from you.
Well, remember,
We go
Danny-
through this and find out.
Well,
So,
Danny, remember, you're dealing with a pack of hyenas here, so you gotta keep things in perspective.
Really quickly, I want to give an analogy. Well, not really an analogy because it's something that actually happens to kind of help put this in. Would you agree that at the how many bar is Earth's atmosphere at sea level? Does anybody know right off the top of their head?
760.
None.
Okay.
Y'all have no lives if you know that answer.
I don't know it.
I'm just kidding. I'm just
How many
kidding.
bars? It's like 14 pounds per
Bars,
square inch. I'm not sure what that is in
No.
bars.
Oh Jesus!
Hold on, just give me a second here.
101.35 or something.
I don't know. What the fuck is ATM? I asked for bar. Are you fucking kidding me?
ATM is atmospheric pressure.
Yeah, I didn't ask for
okay.
an ATM. I literally put
Convert.
bar in, and it's not fucking telling me. You'd think that it would just pop up, but I guess Google doesn't fucking understand how to work.
Wait. I'll get it out of Google. Give me a moment.
make something up, Leo. Just make up.
I don't want to make something up.
It doesn't matter.
I'll get it out of Google. Give me a moment.
760
Leo.
like
Leo, let go.
MHD.
Feel
I gotta
the
do this in 2 steps. I know a way to do it. It's just gonna take me 2 steps. Okay, so what do we got?
It's 1.01 bars.
Okay.
So I found it. Okay, so Danny, would you agree that at 1.01 bars of pressure, water boils at 100 degrees Celsius?
Look, I'm going to
or
grant you.
No.
all the-
kilopascals.
Hold on, I don't want anybody else to talk.
I will grant you all the empirical data. I don't know. I'm an ignoramus when it comes to empirical data, right? So
I
yes,
know where you're going with this, by the way, Leo.
So you agree that at 1.01 bar of atmospheric pressure, water will boil at 100 degrees Celsius.
Yeah, I'll
Okay,
grant that.
except when it doesn't, like when you go in an airplane. But what did you do? You changed the conditions. You reduced the bar, and thus the amount of energy needed to convert that water into a gaseous form. So water boils at 100 degrees Celsius at 1.01 bar of pressure, except when it doesn't. And when it doesn't, you've changed the conditions. We haven't observed that in nature where something doesn't happen, but none of the conditions change. Well, there might be some areas, so you get into quantum level of reality, but we don't have to go that deep into it for what I'm saying. We don't observe that in nature. If something consistently happens, it's because the conditions haven't changed. If what's happening somehow changes, generally speaking, it's because the conditions under which that happens have changed. And so it's even if marginally different outcome has occurred. That's what science does. That's how science works. So F equals ma is a law of motion, but it doesn't apply universally everywhere in reality. But that doesn't mean we don't utilize it as a law.
Yeah, and look, I'm not saying any of this. There could be you can talk about a number of instances in which there is that case, and right. But taking your example, saying that given these conditions, water behaves in this way, but obviously, right, if you just negate those conditions, it doesn't happen, right? So it still doesn't escape the kind of bivalent, tautology. But I think we can say what did I if I missed it, then I want to know about it.
Your mic is echoing.
Well, this comes back to what you were saying earlier about all things being equal. I mean, if you change the air pressure, all things aren't equal anymore, and the law that can be observed at sea level, at atmospheric pressure of sea level on Earth isn't going to apply. If you're higher up in the atmosphere or the air is thinner, it's also not going to apply at sea level. If you're in a barometric chamber where the air pressure has been changed at sea level.
Yeah, but I think when we give those kind of clauses, right, we're saying given the right conditions, and we can be more informative about what those conditions are.
And this is where scientific theories come in handy because they can help to predict in advance what will happen when you do change some of those things.
Yeah, when you change the conditions. And there are some times in science where you can change the conditions. Some of the behavior of the system will change, but the underlying physics describing it doesn't change despite the fact that you can measure it in different ways. In fact, we have a name for that, and it's called gauge theory.
I'm missing the disagreement. What is the disagreement here?
I don't
That just
see why-
because laws of physics only hold in certain scenarios doesn't mean it's not, I guess, feasible to call them laws.
Well, look, if you mean law in the way that there can be exceptions to it, then there's no problem. But it's not what I mean. The idea of a principle, the idea of a law is that, my notion of a law is that if we were to see an exception, that would falsify the law. I thought that's what science was built on.
Well, it wouldn't falsify the law to
how
its
you
scientists
interpret the
because
law.
they're changing the conditions of the system. No physicist would grant that like F equals ma is false in quantum mechanics because it's not something that applies in those conditions to begin with. So it's not about being true or false. So the scientists wouldn't really consider these violations of the laws because the laws only describe something happening in particular conditions right off the bat. So if you violate those conditions, you're not even talking about that law anymore in most instances.
Yeah, I mean, then...
I believe I can clarify that. I believe I can clarify that, Danny. If what he was just talking about a little while ago, if we say, for example, said, water boiling at 100 degrees Celsius is a law because we've consistently observed it. If it's assumed that is meant to be at sea level, if you're, or at sea level air pressure, if you're not at sea level air pressure, you're not going to get that result. And yes, that would be an exception to the way that law was interpreted, but that doesn't mean that the law itself was violated. It's just a question of under what circumstances that law actually applies. And sometimes, because of the fact that those laws are descriptive of observations, sometimes they are restricted to only working in certain environments, and that's not written into the law. Because they weren't tested elsewhere.
An even better example would be c, the speed of light. Anytime you see c on an equation, and this is considered a constant, which is equal to a law. But the thing is, anytime you see c in any equation, if you were to apply that to, say, that light, the speed of that light through some medium, you wouldn't get the right answers. It's always assumed that you're talking about the speed of light as it free streams in a vacuum. And we still consider it a constant, despite the fact that mediums can change.
Look, this is the way, we've lost sight of the dialectic. We started with that there's no necessity with respect to laws, right? But then you're saying we can talk about caeteris paribus clauses, right? And or laws, but then you're conceding that there is necessity because you're saying, giving the XYZ conditions, there is something that not even ought follow, that will follow from this kind of description.
Actually, no. I would argue science says that it ought follow.
Yeah.
Well, I don't mean to say ought in the normative sense. I mean like it will happen, right? We could expect it to happen or something like that.
That's not what scientific. Yeah, expect yes, but that doesn't mean that you're going to be right.
The problem I didn't mean to say ought.
We're talking about consistent observation.
The point is that there's necessity at the end, which is what y'all were denying. Y'all were denying necessity.
There's not necessity.
I'm not talking about necessity.
Given the conditions, it follows, right? That's
something follows based on our best expectations and predictions and observations.
Our best expectation is that it will follow. That doesn't mean it necessarily will. Laws in science, laws aren't like that. They're based on observations, and like I said with the swan thing, maybe there's a black swan out there somewhere, and you've just never seen one.
The point is that
it does not violate the observation.
Are we disagreeing or agreeing that there's a necessity? There's a necessary aspect to laws. Is that what?
Not scientific law. No.
There is no. Okay, so in caeteris paribus laws, is there not necessity?
I don't believe so.
Well, then that means that under the conditions you could have otherwise. How are they laws at that point?
Because that's what we decided to call them.
I don't understand.
It's a name.
I'm not following.
It's a name. We're telling you what that name means. It's a name.
I mean, you don't even know what you're got. I mean, think about the cases that you gave me was, look, the water will behave in this way given these conditions.
Yes.
Right. That's a kind of necessity there.
That's not a necessity.
Given the conditions, X will follow. But if given the conditions, not X will follow, in what sense would it be a law?
But it doesn't mean
we don't expect it to change in the same conditions.
It doesn't mean that condition has to be included in the wording of the law. That condition has to do with the actual physics of the world that the law was describing. The law could simply state that water boils at 100 degrees Celsius. That's an observation. Water does do that. And if somebody happens to be at sea level and they run all kinds of tests and consistently water boils at 100 degrees Celsius, they could say, well, this is a consistent observation. They pass that on to other scientists. They say, look, I've made this consistent observation. And other scientists also at sea level test their observation and they find the same thing. And they say, yeah, this is consistent. Okay, we've got this law we can use. And the idea is to be able to talk about things. So they say, okay, now we can refer to this law and we can write papers and we can refer to this law so we can kind of shortcut the whole thing of having to describe all these tests that have been done and just speak of this law.
Look, you're just giving an epistemological account of how we come to know laws. That I'm less interested in. Right, I'm talking about the nature of
how
law.
it is useful in science and
I'm not disputing any of the practicality of assuming whatever kind of proposition to be true. It could be false. It doesn't matter. It could be practical.
That's all they are, is a tool being used in science to try to get as far as a theory.
No.
So
to try to get to something more useful. Sorry, go ahead, Erika.
No. Then my thing is quick. So I've been mulling over the junkyard thing again. And I wanted to ask Danny, if a vaccine was 99% effective, would you tell someone that the vaccine worked?
Yes.
Okay, so what if you create a new vaccine, and this new vaccine, to our knowledge, is 100% effective? Would you tell someone that vaccine worked?
Yes.
Okay, now what if someone said, hey, I can think of a hypothetical situation where the vaccine no longer works. Would you still say that vaccine works?
Yes.
Okay, so in the context of our junkyard example, I think that creating a hypothetical is fine in the sense of a mind experiment. And I know I said this earlier, but I'm just kind of summing up my thoughts. But I don't think that you can use that.
No, you miss. Let's take let me explain what I was trying to say using your vaccine example. I'm saying that given the hypothetical, right? If that came into fruition, those observations that seem to disconfirm a kind of satisfactory percentage, we would then discard the belief that it's a workable vaccine, right? It's a vaccine that works. So in the case of whatever kind of biological principle, I'm saying that if actually it happens that a fly was produced by a tornado, none of the biological principles go out the window.
Sure, it would become analogous to the 99%.
That's why it's disanalogous. Do you understand why there's a disanalogy there?
I understand in the sense of a 1-to-1, yes, but the only kind of point that I was trying to make is that when we're talking about like colloquially, when something works or
echoing,
whatever.
I don't hear an echo.
It's really bad.
I can't hear it.
Leo, that might mean it's you.
Yeah,
I don't think it's me.
I'm just kidding, dude. This has been.
I don't know. I do hear some echo when Erika's talking, but I think it's happening inside of where she's at, and I'm not sure what that is exactly. I don't hear echoes of other people. So yeah, just a little bit of echo when Erika talks. I still understand what she's saying.
This has been a baller chat, but I'm gonna scoot here soon. But
I wish you wouldn't, but you know.
I know. Sorry, I'm a couple seltzers in, and the old fiance wants to do some couple bonding activities in the form of playing video games. So that is what I think I'm going to do.
Not sure what the seltzers is, but okay.
I'm just having some White Claws. I don't say White Claws because people descend upon me when I admit that I drink White Claws. Like,
you drink Claws, huh?
Yeah, no laws on the claws.
I have no idea what that is. At any rate, it's been great having you here, and really enjoyed the conversation. So, thank you.
You're a very nice guy. I just want to say something nice.
I'm gonna mull over our conversation, see if I can't come up with a better way of trying to say what I am trying to say.
Say what you need to say. I listened to the playback on my YouTube, and I didn't hear an echo.
Huh. Well, I don't hear one now.
Yeah, get Rex Speed.
Yeah, it seems to be gone now. Speed, you still getting it? The echo?
No, I think it's good. Erika, I caution you to reconsider mulling it over.
I caused you to reconsider it?
No, I caution you to reconsider.
Cautions you.
Listen, I'm always down to see if I've missed something, because God knows there's always the possibility I have. So may as well
Danny
give
and-
it a look.
Danny and
It
I
comes
are
with
going
being
to
a
have to get a room
scientist.
soon.
We're gonna have a room for what?
Pass this shit out.
Yeah. I'm gonna.
That
I'm gonna
sounds
leave
very
it there.
sexual, Speed.
I know. That's, yeah.
Well,
yeah.
that might be
Depending
very
on what he means by hash.
I don't see it that way at all.
Danny is taken to my knowledge, Speed. You don't want to be poaching like that.
I'm what?
Speed-
I'm taken.
Speed just-
Yeah, don't you have a
Speed-
girlfriend? Yeah. Am I wrong?
Oh,
on that?
yeah, no, yeah.
Oh, that kind of taken.
I don't know.
Wasn't sure
You
what
said
was
you're
meant to be.
taken, and that's not, you didn't think of like you didn't know that she meant you had a girl. Wow,
Well, I was really
you
promiscuous.
really are a fucking philosopher.
I was
thinking
really
threesome.
promiscuous before I met her, so I have to like adjust. I'm like adjusting my tendencies.
Monogamy is a hell of a drug, but we are a pair bonding species. So
I used to be very
That
monogamous,
we are,
and
yeah.
then like I went crazy
Well,
the last
most-
2 years, and then now I have to remind
Most
myself. I have a
members
girl.
of the species, anyway.
all right, dudes. I'm gonna scoot on out of here. Y'all take care.
Hey, Erica,
Peace out,
thank you.
bye.
Thanks, Erica.
America.
Thank you. Immutable. So, do you want to run this thing so I can go watch television and eat stuff?
No,
Jesus Christ.
fuck you. I asked you at 12 o'clock.
When was the last time you ran something?
You're stuck here
I
with us.
asked you at 12 o'clock when the hell were you doing Is the Cell a Machine Part 2? And just so happened Speed to sleep.
Yeah, I might offer to if I thought I could, but I don't think I could. So I don't know enough about what all would be required.
Here we go. Guys, quit pulling a praise Gavin on each other.
What's that? Praise Gavin.
You're in charge.
It's-
I'm leaving.
No,
I'm
I'm all right. I can keep adding myself back to the stream even if you kick me.
Okay, boot me out of the stream now. I really want you to. Please.
Nope, I'm not.
I'm going to say goodnight.
I just love you that
All
much.
right. So are we not recording anymore then, or it's still going to be
No, we're
recording? Or out of the
still live.
We're still live, but I
Okay.
think we should end it. I think it's.
I mean, I figured since you started the stream, if you get booted, is that going to end the recording?
No, actually not. I can just go backstage, or in fact, I think I can disappear. Immutable's on it, so he's got the keys. He's
That
my
also
man in
means I have
charge.
power.
I'm relying on you, Immutable. I need you. I need you right now.
Oh, say it harder. I need to.
I need you,
I need
baby.
to really feel the conviction of the statement.
I'm curious about that immutable in your name. I'm guessing that's something you picked as opposed to like your parents imposed it on you.
It's probably
But,
a filthy determinist.
I can
what I'm
falsify
curious
that.
about-
Watch. Okay,
what I'm
falsified
curious
it.
about though is it a reference to unable to be changed or unable to be silenced?
Both. Both, actually. So,
Oh, okay. Just curious.
I know.
It's, linguistic curiosity.
People
He
call me,
immu-
I call myself immutable. It happens.
He immutably doesn't show up on time.
I show up whenever the fuck I want to because I'm that fabulous. Fuck you.
So that's a law, huh?
I think you should boot me now.
I'm okay.
You guys want to quit?
Yeah.
What are we quitting?
What are we putting exactly?
By the way, Danny, if I can say so, I think you've been a really good sport about the whole, sticking to your, trying to get your point across, and I hope we've all learned something in the process. I mean, we're intelligent people having a conversation. We each know things that each other doesn't, and we each have understandings that each other doesn't, and I think this is beneficial all around. So. Good job.
Ditto.
Well, yeah, it helps me understand my own views, or at least articulate my own views, and that's always been very difficult for me to do. So I appreciate it.
you actually help us basically double down and understand what we're talking about too.
Yeah, and it should be able to help you change your own views as well when there is cause to do so. And,
my views have changed quite
and the same for
dramatically
us.
over the last 4 years. I dropped moral realism like a hot potato. That was the first thing I dropped.
Wow.
Like,
yeah, you're gonna have to pick that back up.
So now y'all better be careful. Everything is permissible.
That would explain why you dropped determinism then. Okay.
No, well, I'm not a hard determinist. I'm a soft determinist.
So, would you consider yourself? Would you consider yourself a compatibilist?
Yeah, I'm a compatibilist, but I think the future is open, which is not very common.
Well, so I believe the future is open in some sense.
So the opposite of hard determinism isn't easy determinism?
Nope.
You're such a boomer.
I would say I think the future is more or less closed.
Yeah, I think that's not good, but whatever.
It depends on what you mean by open and closed.
Meaning, like, if I was deliberating that between X and not X, that either is possible.
I would say yes, that either is possible.
But if there are laws of nature, and if you think everything is natural, then there's only one outcome.
Not necessarily. Multi-universe theory is an example of where two contradictory things could both happen. You're just not going to observe them both because
I don't know what you mean by contradictory there.
Well, in the case of a diverging multiverse, you might, for example, have a point in your life where you could make a decision to do something and also make a decision to not do that thing. And if you look at the universe as like, if you look at the universe you're observing, what you can see of the universe as like a slice of the whole universe, which is, in some sense larger, then what you end up observing in each slice that you're in that universe might not be the same. So you'd only be aware of one of them. Your brain within one slice of the universe would only be aware of that slice, but in other slices of the universe, in other aspects, other directions from that past into various futures, you may have both made the decision to do it and made the decision not to have done it. And then you may have, in those cases where you decided to do the thing, in some of those branches you may have succeeded, and in others you might have tried and failed.
Okay, Andrew, are you there? Andrew, are you there? Yeah. Okay, I need you to write a 3-page report on what he just said. Thank you. Send it to me.
You can look up what he just talked about because it's often referred to as the Everettian foundation of quantum mechanics.
What is this notion of like I made this?
I've never heard it called that.
It's called the Everettian interpretation of quantum mechanics. It essentially says that
I don't think I have.
All possible worlds of quantum mechanics are equally real, but not all of them are actualized.
Right.
Okay, well, that wasn't quite what I was saying. Maybe that's why I've never heard it called that.
I would say that in it, all of them are actualized. You just only experience the actualization of one of those timelines.
Is that all you're saying? I feel like you're saying more.
Also, not all hypotheticals are actually possible.
No.
I think he was saying more than that. He just said it. Destin, God, Immutable, you're so motivated. It's crazy.
He doesn't know. He's not very familiar with the Everettian framework, I imagine.
Within that model, also, not all hypotheticals are possible. So it's important to point that out. When somebody says, when somebody says all things are possible, it doesn't mean that you can have.
I was like, and then it's contradictory and all this stuff.
I don't mean all things are possible in the sense that like I could shit out a unicorn. I mean all things are possible in the sense.
Well, that's logically possible.
I swear to fucking God. I mean that all things are possible that are inconsistent with the laws of physics and chemistry and biology and geology and so on and so forth.
Yes,
I call it a generalization of Murphy's law that all things, anything that can happen will, but it has to be something that actually can happen, not just something that hypothetically can happen.
Well, the things
what does that even mean?
That's tautological though, because the things
what it means is that the conditions have to be right for the thing to be possible. And if there is only one possible outcome, then you'll only get one possible outcome.
Okay,
but
that
if there
is
is actually, if there is actually in physics, if there is actually at the quantum scale, for example, the ability for say, for example, you've got an electron that is in some sense in one place and in some sense in another place, and being in the one place causes one result, and being in the other place causes the other result. By some interpretations of quantum mechanics, you get both results. But your observation will only be able to see one of those two results. The other one is observed by another you, or a different slice of the greater you
on a different timeline.
The issue with that, though, is that
if you can call them timelines,
the issue with it is that it's self-referential in the sense that the set of things that actually do occur, the things that do occur, right? They're the things that we observe occurring.
Yeah. I mean, well, that it is self-referential in that sense, and it's not the only issue with it. There are others, but yeah, I mean that's the way physics is, though. Physics is describing our physical universe. Physics basically says the universe does this, and the universe has to agree with it, or physics is wrong.
Fucking Icarus. He's asking if we're getting dumber and didn't number one didn't spell out evolution all the way. What is an Evo atheist? I don't know what that means.
Evolution?
And number two, yeah, I was being smartass. And number two, he didn't put a question mark on it, but we're getting dumber.
He's an idiot.
Emo atheist. Is that similar to an emo atheist, or
I don't know what it means.
Where
does it have to do with what kind of makeup they wear?
Tonight.
Well, I'm gonna go over there. I'm gonna be nice and good little boy over there. So
yeah, okay. You're gonna go suck dick.
Have fun, Danny. Please try not to help people.
That's homophobic, but that's okay.
They love
take some of your assertiveness from here and spread it around.
Yeah, spread it over there, man.
Y'all are, I think the thing is that we're gonna laugh about it after, right? We're gonna laugh tomorrow and be like, oh, well, that was. Well, did you remember what? Leo said, ha 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 ha, that kind of stuff.
Yeah. Well, that's the thing.
Someday.
That's the thing. We're not afraid to have those, somewhat confrontational, conversations. Some people are. So yeah, in another environment, maybe you might have good cause to be more restrained. Here, you don't have to.
Danny, I enjoyed you. Tomorrow, I'm going to figure out where you live on the internet.
I live. What do you mean? Oh, like what? My address and stuff?
Well,
we're going to nail down. We're going to nail down your precise atomic location.
Yeah.
Which vat his brain is in.
Yeah, we want to find out which vat your brain.
Yeah,
I don't need a brain.
Yeah, we want to. We want to lower the vinegar content.
He had a brain.
Vinegar content.
Have y'all seen Wizard of Oz? He didn't have a brain.
We are going to have a talk, Danny.
Oh, so many talks.
We got to do a one-on-one, Danny.
I'll go easy on you.
That's kind of you.
You're getting feeble speed. You hear that?
Young whippersnapper.
So what was this thing about Evo something or other?
John Maddox is having a live stream where he's going to complain because I kind of told him that I didn't really like him. And what else did I tell him? I told him he needed therapy. What else did I tell him? Anyway,
at least you didn't tell him his mom had an abortion. Oops.
Okay, so he's.
But hold on, Speed. Did you tell him that he's a
little?
Huh?
I said, did you tell him that he's a grifter?
I think somebody else called him a grifter. And I said not to feed the grifter.
Did you tell him he's a blowhard conservative?
I actually find LPP's titles so funny. Like, our emo atheist getting numbers.
Nice he is?
So funny. Okay. It is really funny to me, though.
Look how nice he is. Somebody pointed out the question mark, so he gets all triggered, and he fucking look at the thumbnail, jackass. Search algorithms don't like punctuation marks.
Oh,
what the fuck are you talking about, John? Are you out of your fucking mind? They
just
depends on the search
filter them
algorithm.
out, John. They filter them out.
Are y'all telling me you don't appreciate LPP's titles?
On the search algorithm.
They are so funny to me. They like are atheists I don't know, I don't know. I gotta read some of these.
atheists are evos somehow, or evil.
No, there was.
Here's a good one. 4 ways to trigger a new atheist with AFLPC, or Atheist Fantasyland Projection Complex. The little what are they, anagrams or whatever that he comes up with. What is it?
Okay, Danny, when you listen to John,
there you go. The acronyms that he comes up with.
Atheist Fantasyland. I love it.
John,
it's so
Danny,
great. What?
Danny, when you listen to John, you must catch where he is like he's a real jackass. I mean, really. I mean, you must have noticed that, right? I mean, he never actually.
I told him that he's pretty abusive towards my atheist fellow kin. But
no, he never actually makes an argument, like a real argument. Well, he just kind of snorts and talks about all the papers he's read, and he snorts a lot.
Well, you kind of do that to me with naturalism stuff, so it's not. I mean,
fuck you, Sonny. We'll have to.
You just say it's BS, and I don't understand anything, and philosophy and science are different. It's not. None of those are arguments.
Wait, are you saying he says he doesn't understand anything, or he's saying you don't understand anything?
Me. I'm just saying that this happens all the time to me.
Danny is so fucking lost. I don't know how.
Could have been taken either way.
You see right there, Speed.
Yeah, I mean,
do the same thing as LPP, right? No, you're not as abusive, but you're not abusive. I think he is a little abusive. It's a little amusing, but some of y'all do the same stuff. It's,
like who?
I'm
not saying anything.
He kicked me out. I was on his channel for a little while. Which, I was thankful he had me in there for a while, but he kicked me out for asking a question of clarification on something that
Jack, I would kick you out of my stream too. I'm sorry, you're a nice guy, but you could not.
Well, I mean,
he kicked me out just for asking him who a person was. I mean, the person was Landon Kurt Nolan.
How can you not love him for that? Like, I mean,
no, I started dying after he did it because I gotta be honest. It was more the reason. It was more the person that I asked him about. I was just like, "Do you know who Landon Kurt Nolan is?" And I went backstage and then was kicked completely out of the studio, and I just started laughing. And by the way, for those that don't know, Landon Kurt Nolan literally helped to develop the internet. And he was talking about information theory and coding and computers and all that stuff.
That's right up there in my field, and I didn't know that. So there you go.
Yeah,
I've met him before. I think either him or I have met him before actually.
Icarus makes a good point here. The creationists are convincing me of genetic entropy.
Well, if you can call it that, yeah, actually, somewhat. But that is a very slow process, and there is still natural selection going on. It's just it's within the confines of human society, and so yeah, I mean people if somebody has a genetic mutation that leaves them with an IQ of a single digit, they're not likely to do real well in this world, and sure, they might manage to reproduce that way, but the odds are against it.
They be raping.
I think some of these creationists have demonstrated the first proof of concept for what I'll call negative IQ.
Yeah.
Such a low IQ that it collectively.
Just for the record, if I ever say stuff like that, it's because I'm just emotional. I mean, if I call anyone stupid or idiot or low IQ, I don't mean it. I'm just mad or something.
No,
I have actually mathematically quantified that negative IQ concept. It was a long time ago, but because generally speaking, IQ is about what you know compared to what you should know for your age. It's an intelligence quotient of how much you can demonstrate you do know versus how much you should be able to demonstrate for your age. And if somebody's asked a question and their answer is I don't know, then that should be 0 points toward that sum. If their answer is the exact opposite of what they should have, what the actual reality is, then yeah, maybe they should be given a negative IQ point for that. Subtract one, because they didn't just not know, they anti-knew.
Well, the thing is, if it's creationism, it's not subtract one, it's minus 150 points. Yeah.
150. Why?
Yeah, no, I'm sorry. Creationism, straightforwardly, specifically young Earth creationism, is a literal denial of reality. It is a delusion.
Well, that's what I'm saying. You'd subtract one for each thing they've got, like the exact opposite of true. I mean, if you put the measurement of each answer on a scale, like from positive 100% being absolutely correct and negative 100% being absolutely wrong, then yeah, you could actually get negative IQ points that way if the test was designed to be able to do so.
You think truth is gradential?
Is what?
Gradential?
Oh, in some cases, yes.
Oh, that's insane.
Same thing about philosophy.
I mean, you think some propositions are more true than others?
So you're asking if truth is a gradient?
Yeah, the truth is it's like an either. It's like an either or. There's like something like take a proposition. It's not going to be any more or less true than another true proposition.
Well, there's varying levels of truth, so yeah.
Oh, that's ridiculous. Y'all don't mean that.
No, it's not.
Yeah,
wait, you think that the proposition
you can be partially correct about something.
You think the proposition 2 + 2 = 4 is more true than the truth that there are like 8 planets? I think there are 8.
I think, for instance, the question of is a cell a machine in the context of biology, it's appropriate sometimes to answer yes to that because you're a biologist and you're not really thinking about things that they're at a more fundamental level.
I'm not talking about what's probably true. I'm not talking about that.
No,
I'm talking about if given a true proposition and another true proposition, how is it possible that one's more true than the other? That makes no sense.
Would you say that 2 + wait? Are you saying that 2 + 2 is always equal to 4?
I think it's an identity relation, so yes.
No, it's not always 4.
Okay, what if you're in base 4? What is 2 + 2 then?
I mean, you're just changing the meanings of the terms.
No, I'm not changing the meanings of the terms. I'm changing the environment. What if you're in base 4? What is 2 + 2 then?
They just mean something different.
It's the same value, but it's the same value, but it's going to be 1 0 rather than the digit 4 as a result.
Yeah, you're just changing the meanings of the terms.
And in that sense, there is a sense in which when you say 2 + 2 is always 4, there is a sense in which you're correct, and there is a sense in which you're not correct. That's why I said there are gray areas in that respect when it comes to truth. There are things that are partially true. There are things that are true in some ways and not true in other ways. And in that sense, you could actually make a gradient
you do this whole thing of equivocating,
completely right.
And yeah, if you're equivocating or changing the timestamp or anything like that, you're sure think the truth value changes. But I'm saying that if some proposition is true and a different proposition is true, does it make sense to say that one is more true than the other, despite whether it's a contingent or necessary truth? I don't know what you're talking about.
It can. Again, it depends on what the propositions are, because propositions aren't always very precise. And if your proposition lacks precision, if your proposition
I don't even know what you mean by precise here.
I just
precision doesn't apply to propositions.
Yeah.
Well, what do you take a proposition to be?
Well, I gave an example. 2 + 2 is always equal to 4. That's a proposition.
Yeah, it's just all a proposition is that which can be true or false.
Proposition is 100% true, and there are contexts in which that proposition is 100% false.
I'm telling you what a proposition is.
If you consider all of the possible contexts, you do have a range of cases in which it's true and a range of cases in which it's false.
It's like stuff. This is the stuff I hear that are sort of. I mean, look. The point is that a proposition is that which is true or false. Truth and falsity are not on a gradient. Now there could be contingent truths and necessary truths, but a contingent truth in one possible world is just as true as a necessary truth.
Well, I would actually agree with Dan.
And electrons can only be in one place at a time, right?
I think that the truth value of a proposition might vary in terms of whether the truth value applies to the proposition might vary depending on the particular conditions or environments to which you're applying the proposition. But once the proposition has the truth value, it either does have it or it doesn't. It doesn't have it halfway. You can't have one proposition that is halfway true. That's not how it works. So in that sense, no, truth is not does not exist on a gradient.
Yeah, well,
it's either or.
that to relate that back to physics, that is your wave collapse right there. But you do have to get it into that specific
Leo, you can
environment
deal with this.
first.
I'm gonna.
You have to have that wave collapse before you can do that with it.
Well, yeah, but prior to wave function collapse, none of the potential eigenstates have a truth value to them. But none of them have a false value applied either. They don't have the opposite of a truth value.
They have probabilities.
Mm-hmm.
Yeah, and that's all I'm talking
the probability of it's in some ways you could say that you're assigning the probability of a truth value being applied to that particular state.
Yeah, and if somebody makes the statement, 1 + 1 is always equal to 2, if you consider all of the environments in which that could be considered, and all of them together says that's not actually a true statement. That's actually a false statement. 1 + 1 is not always equal to 2. But in general, in the general understanding that most people have of mathematics, the general usage most people have, then if you narrow it down to that, then it's true 100% of the time. So you have a case where it is 100% false, and you have a case where it is 100% true, but they are dependent on how you collapse that wave function or whether or not you've collapsed the wave function. If you don't collapse the wave function, then it's a probability. And when you're saying always, it is always true. Well, then if there's any probability at all that it's false, the statement "it's always true" isn't true.
Mm-hmm.
Speaking of wave functions,
I think when you talk about like the wave function collapse thing, the important thing that a lot of people miss is that even though you don't know the value before the wave function is measured, it has to be somewhere, right? Like, and that's
but it doesn't have to be just one somewhere. It actually can be spread out.
Well, right. It has to be somewhere, but prior to measurement, it isn't anywhere. But it's also not nowhere either.
Well, we don't actually know whether it's somewhere or nowhere or anywhere.
Well, I'm thinking from textbook quantum
mechanics. We just don't have that information.
In textbook quantum mechanics, a quantity is neither assigned nor it's not in a state of being assigned.
Right.
It's not in a state of being not assigned, because that's just not how we talk about it prior to observation.
Mathematically, because mathematically, that's all the information we have. What I'm saying is there is information we still don't have, and we can't say what that information is.
Mathematically, mathematically, even though we don't know the precise location of the particle before measurement, we're ensured that it must be somewhere in the universe. And the reason for that is because the wave function
narrows it down.
Well, but the reason we know that, though, the reason you can claim that is wave functions are normalizable, right? You can normalize a wave function to say that it exists within the universe.
Yeah.
And then you have to square its absolute value to actually assign a probability to some potential outcome of the measurement.
Yeah, and if the wave function has encountered its exact opposite and been in a sense neutralized, then even though what you knew in advance might have said it exists somewhere, maybe it doesn't.
Andrew, did you have anything?
Oh, I was just gonna say I'm pretty worn out, so I'm gonna make like an electron and collapse my wave function out of this room.
Sounds good.
All right.
I think the issue is in saying. Well. I think the issue is in saying, like, if the electron did exist somewhere, it could be in figuring out where it was, right, before the function.
Yeah. Well, the thing is, we don't really know actually yet what it is. So when we talk about trying to find out where it is, I mean, maybe an electron is not one thing. Maybe it's a swarm of things, and that swarm of things might, in order to be detected, might have to come together and join together as one detectable lump of the swarm. But we don't know yet. And in that sense, maybe it's in a bunch of places at once. Maybe it's in only one place. Maybe it's in some sense not anywhere at all. Maybe it's like a wave that goes up and down, and somewhere along the way it's neutral, and there just isn't any peak or trough. But the thing is, we don't know yet. We know what we've been able to observe, what we've been able to measure, what we've been able to predict. There are still unknowns, and it is a valuable discussion to talk about what those unknowns might be, because that may help us figure out how to discover what the unknown is and how we can actually find evidence of it. But in the meantime, it's still an unknown.
Wait, what particularly is an unknown?
Various things. In that particular case, I was referring to exactly what an electron is. We know
we've got a pretty idea of what it
behaves.
The
we have a pretty good idea, but we don't know.
Is that
we don't know
not
what
really
it's made of.
things at
If
all.
it's made of anything, we don't know whether or not an electron is made of anything at this point.
Well, an electron physically, I mean, quite frankly, an electron is essentially an immaterial thing, because it isn't material. It makes up material, but it is still physical and engages in physical reactions with other things. But elementary particles are essentially excitations of fields of energy. Now, though, people might ask, well, what are the fields made up of? They're not made up of anything.
Yeah, as we can measure them, that's what we've been able to measure. But like I said, we don't know the nature of what's underneath that. At this point.
There might not be anything.
Maybe we never will, and maybe there isn't anything underneath it. But that's what I'm saying. That's an unknown. That is something that's that's beyond our current knowledge. Maybe someday we will prove that there's nothing underneath it. That's as far down as it goes. Or maybe someday we'll prove there is something underneath it. If you look at the work that's being done by Stephen Wolfram's physics team, they are on a path that could very well lead to figuring out what some of those underlying things are. And the work they've done so far indicates that there actually probably is something underneath it. But but what the exact nature of that something is will have to be, or at least precisely enough to be able to show that it models our universe accurately enough to say that's our universe, not a similar universe, will have to be determined before they're able to then say, okay, well, this is the underlying nature. Right now, they just have a programmatic model that was not designed, for example, to have any of Einstein's laws in it or anything like that. And some of those things are emerging from observation of this model. So you run the model and you look at the numbers that come out of it, and they're finding laws of physics inside of the model that they didn't put there.
Somebody's got some honking going on in their neighborhood. It's not me.
That's outside behind me. I'm in downtown Los Angeles, so yeah,
okay. Yeah, that explains a lot. Well, I'm gonna scoot on out of here. Should we just shut it down, because it has been going for
might as well
2 3/4 hours.
Could do that. I don't see the chat. Is everybody in the chat all right with that?
Yeah, well, they're gonna have to be, I think.
Anybody in there say no? Please don't go.
All right, guys, we are going. We are out of here. Goodbye.
Are we going? Are we going? Good. Goodbye.
Take care.
Bye, everybody.
Are you ending?